So I was wondering whether there was a way that we could move over from using bare machine level system calls and provide something that looks more like a library interface the user space can call. There's been some recent discussions and work that suggests that this is an interface that may work. So the generic VDSO work, for example, has looked at deploying the VDSO interface across multiple architectures. And basically my work explores some ideas about how we might make use of that for all system calls. So I'll just take a moment to explain what I mean by ABI. You all know what this means, of course. Application binary interface is the machine level or assembler level interface between user space and the kernel. But there are some different ways we could interpret the notion of what the kernel is. So Linux is a project. It has a Git tree. It's maintained by a community of people, some of whom are here. It also might be viewed as the binary blob that the bootloader loads and that runs in privileged mode, or you can view it as an API or an interface where you don't necessarily care about how it's implemented. In Linux land, what tends to happen in practice is we have the Linux kernel project and we develop the blob that runs privileged. And that blob has access to the privileged features of the CPU. And user space is mostly the other stuff. It's not developed specifically by this community, and it doesn't have access to privileged CPU features. And the ABI is the interface that those two things use to talk to each other. Mostly where I say kernel in this talk, I'll mean the thing that runs privileged, though obviously not everything that's part of the kernel or part of this project runs privileged. So what's the impact of that? Well, in practice, a lot of the stuff that we develop ends up in the privileged code base of the kernel, which means we tend to accumulate in privileged mode some glue and legacy stuff. Features that are valuable but have been superseded by more flexible interfaces over time, backwards compatibility stuff, and some things that seemed like a good idea when we originally added them but may not seem like such a good idea now. But because these are exposed via this low-level interface, they tend to be stuck running in privileged mode forever, and we can never get rid of them unless we are happy to break backwards compatibility. So just to give some simple examples of some odd cases, there are some calls like personality and set robots list, which really do nothing more than access a variable on behalf of user space. Some of the signal-related syscalls also don't do much more than that, although they can be a little bit more involved. But the impact of exposing these in the syscall ABI is that we have an inevitable trap into the kernel every time we call them. Do they really require privilege? Could we just, if they're just accessing a variable on behalf of user space, could we just put that variable in user memory instead? Sometimes there are other concerns. For example, there may be an expectation that the whole call is atomic. Newer architectures provide some ways of ensuring that didn't necessarily exist when these interfaces were invented. So sometimes things that couldn't have executed in user space when they originally introduced might be more feasible to do now. So is there anything we can do to change this situation? Well, the alternative that occurs to me is that we use some kind of user space library interface instead. But if it's a separate library, then we have to ask the question of who maintains it. It's either going to be maybe done in a user space C library, say glibc or Bionic or something else. But those are developed by different communities. They may do different things from each other. They may not be completely in sync with what the kernel's doing. Another option is that it's just a separate standalone library. But again, we can't force people to use it. Different people may invent their own, and again, there's a risk of fragmentation. So it would be nice if we could maintain this thing as part of the kernel project, but not have it run privileged. And if we do that, we have the option to keep it tightly coupled to the kernel version, which gives us more flexibility to refactor and re-implement how things work over time. And we already have something that ticks a lot of these boxes, the VDSO, which is this fake shared library that the kernel can map into user space for user space to call. It's not deployed on all architectures today, but it is on several. Yes?
First of all, the VDSO has problems when it comes to checkpoint restart. So relying on that alone is probably not a good idea. The idea of having a libkernel is something I personally have proposed for quite a long time. If that is, something that people think is a good idea, I am more than happy to take the infrastructure I wrote for klibc, which provides very, very thin layer system calls, and just do that for the system calls that do not require, that do not have wrappers. For example, glibc has its own struct term iOS. You can't implement those things in a library because you will, in a kernel-specific library, because it will do the wrong things.
Yeah, well, it's glibc that defines that interface.
But there is a lot of things in our ABI where all that happens is we just pass things straight through.
Yeah.
And that is something that we could do very, very easily in a libkernel.
Yeah,
and
so I've focused on using the VDSO as a mechanism, but there are probably other ways you could do this. You could maybe ship a library in the kernel or some other things.
Yeah. You might want to state why you're concerned about VDSO and checkpoint restart. I assume it's because of state being held in the VDSO page.
Right, because when you do a checkpoint restart, if you are pulling out, you are now having a potentially, actually most likely, very different VDSO. If your instruction pointer is inside the VDSO, or you have issues with your VDSO data, you could end up in quite the mess.
Yeah.
And as a result, most of the checkpoint restarts implementation these days simply unmap the VDSO.
Yeah. There were some discussions on this yesterday as well, and yes, this. So this doesn't create new problems with the VDSO of that sort, but as you say, problems already exist.
Right, but a library, a user space library can be maintained forward compatible, so that when the checkpoint restart, it also checkpoint restarts the library together with all the other user space stuff. And yes, you're only providing a subset of the functionality that you would in a newer kernel, but you're doing that anyway. That old application can only use that subset anyhow. So in that sense, having it as a standalone library in user space will, inherently resolve that problem.
So the big problem you're trying to solve is legacy, right? We have a lot of, or not just necessarily legacy, but we have accumulated a lot of syscalls already that you pretty much want to just move from kernel space to somewhere else where it's less privileged, which is
potentially.
Reasonable.
And there are some things
that's
which
a good use case.
There are some things which don't necessarily need to go into the kernel at all if we're flexible to change how they're implemented.
Correct. So the problem is that if they already exist, we cannot move them to a libkernel because we still have to adhere to old user space that calls those syscalls, right?
So that's something I explore here, one way of working around that, though it does use the VDSO as a platform, so there may be issues with that, but this is really a bag of ideas, and I want to see what people think. Okay, so thank you for that. I will carry on. So you rightly make the point about backwards compatibility. We can update user space software to call some library, but older binaries are obviously still going to make direct syscalls, and we have to still make that work somehow. We could keep all the backwards compatibility glue in the kernel, but if part of the object of the exercise was to move that stuff out of the kernel, then it makes the exercise maybe a bit pointless. So I wondered if there was some feasible way to bounce old-style system calls back out into user space and have user space handle that somehow. So mentioning this to people, first thing they tended to say was, well, doesn't seccomp do that sort of thing? So I thought I would experiment and see what I could build on top of that. So seccomp gives us the ability to filter system calls and decide whether to allow the kernel to execute them or just trap them back out to user space using a signal. So if we want to filter syscalls based on where in user space they came from, then we need some information about what's sitting in the user space address space. To keep things simple, I just extended the seccomp data structure that's passed the filter with some bounds information to tell us where the VDSO is at the moment. And I envisaged that to make use of this, the C library would install a suitable filter and a handler for this signal on process startup. Now that has a world of issues, but this was just a hack to see what we could get working. So I have some hacks in a Git tree there's some references at the end of this slide deck, which you can follow up later if you want. But just to illustrate, so I tacked a lower and upper bound for the instruction pointer that say whether it's in the VDSO or not. Sorry. Just onto the end of the existing seccomp data. And then I cooked up a seccomp filter. You don't really need to read this, but just to give an indication of how much code there was, it's just checking the instruction pointer against two bounds. If it's within bounds, we allow the syscall. If it came from some other user space address, then we trap the syscall using a signal. This is using classic BPF because I hadn't got my head fully around eBPF at the time, so we probably could do a bit better than this. But anyway, that's the rough scale of it. So when we trap a syscall out into user space, then we need to handle that, and the skeleton handler might look something like this. The details of how to extract the system call number and arguments is obviously going to be architecture specific, but once we've extracted that information, we could handle things in a generic way, much as they're handled in the kernel. So we might have a switch on the syscall number to catch any system calls that we want to do something special with. And then for other system calls, we can fall through and call some stub. For getting this working, I added a stub in the VDSO, which will just make a syscall using the arguments supplied. Because that comes from the VDSO now, it won't be bounced again, and the system call will just be executed. So, does this work? Well, signals are a recipe for invasiveness and interacting badly with things in general. So I didn't expect this to be entirely foolproof. One obvious thing here, the signal frame is generally pretty big, so we're adding quite a lot to the stack footprint of a thread compared with what it would otherwise have required. And to be honest, I didn't attempt to winkle all the seg faults out of this because there are things that you probably can't make work anyway. It was good enough to run LS. It wasn't quite good enough to run Emacs, but somewhere in between there was probably a sweet spot. The fact that things worked at all, I was quite surprised by. There are some other things you obviously can't fix, like if the user thread is already trying to use seccomp for something else, it's not going to interact well with this. As a hack, I intercept the PRCTL syscall in my tree and catch the seccomp commands in there so we can prevent user space from installing any new filters. But User space probably wants to install filters sometimes, so it's not really a proper solution. And of course, this is pretty slow. That shouldn't come as a surprise. We're now turning every syscall into a syscall plus a signal delivery plus another syscall. And even the BPF JIT can't rescue us from that. But it's kind of fun. Probably not the right way to do things. So I had to think about, if we were to do this in a more tightly integrated way, how might we do it? The approach that I took was to basically hook into the front end of system call handling, which, because of the way the code's structured in the kernel, probably has to be in architecture-specific code today. And currently I only wired this up for ARM64, but the concepts, at least, are not architecture-specific. And what I currently did was I bounced system calls by doing something that looks a little bit like signal delivery, but it's much more minimalistic. There's been some controversy about introducing new mechanisms for trapping into user space, but I should stress that this is not a general purpose thing, and I wouldn't propose that there's any API for user space to control this. It's kind of a private interface between the VDSO or whatever library you have and the kernel. So in theory, we have a lot more flexibility to change the way this works between kernel versions and so on. So there's some code showing how I did this in that referenced Git tree. And similarly to the setcomp signal handler case, the handler, which we now put in the VDSO, can catch certain system calls and do special things. It can make one or more real syscalls in response to that, or it can do something that doesn't involve entering the kernel at all, if that's feasible, or a mixture of those things. So in common with delivering a signal, we need to get back to the original call site where we came from somehow. So for now, I push a frame onto the user stack, but this time it contains only those things that are absolutely required. For ARM64, this turns out to be the syscall number register, the stack pointer, because we may need to realign the stack when bouncing the system call, and the PC to jump back to, obviously. And on ARM64, it turns out to be convenient to save and restore the condition flags in the same place. But exactly what this looks like on different architectures could vary. Once we're done handling that syscall in the VDSO, then we need to jump back where we started, and hopefully that you can do that directly. What you need to do there is to jump back somewhere and get the registers back into their original state with a single instruction, or restore the registers and then jump back with a single instruction. On x86, a return will do that, or an IRET. Interestingly, on 32-bit ARM we can do this, but on 64-bit ARM it turns out not to be possible. We need something that looks like an exception return, and user space can't do that. So for this case, and possibly on some other architectures, we need to do a syscall in order to do that return, which is slightly annoying. But in the cases where the VDSO handling of the syscall is going to do a real syscall anyway, we can piggyback on that. So what I did was add an extra flag to the system call number, which tells the kernel to, after executing the real system call, it will also pop this frame and jump back to the original location. So just to give an idea of the complexity, this is what I added in the system call front end on ARM64. We just do a bounds check on the user space PC. If it comes from outside the VDSO, then we push this frame I just described onto the stack. If we run out of stack, we'll have to kill the user task, but that's similar to delivering a signal. Assuming everything's fine, then we set the user space PC to that new entry point, and then we just return to user space after this. If we were within bounds, then we execute the system call for real, as we usually would. So In effect, this is doing basically the same thing as that setcomp filter that I illustrated earlier. A minimalistic no-op handler in the VDSO would look something like this. I should stress that this is not trying to be a C language entry point. So you would have some architecture-specific glue here. But if you do anything interesting with generic code, you can call out to C, obviously, having saved any registers that you need to. But to do nothing and basically reflect all system calls back into the kernel, I just set this flag to make the kernel do the necessary return after the system call, and then I just trap into the kernel. And we stick unwind directives in here so that user space tracing and debug tools can unwind through this frame without needing to have hard-coded knowledge about its layout. So how does this compare? Well, from the point of view of what user space sees in terms of behavior, it's much closer to a bare system call than the setcomp case was. The stack overhead is much reduced, and it's worth observing, although I didn't try to make this work, because system calls from the VDSO are never bounced, there's no actual recursive bouncing here. So we don't, strictly speaking, need to put this data on the stack. If we allocated a per task user space page, then we could store the return information statically in there, and then we don't need to have multiple copies of it. So we might be able to reduce the stack usage to 0. A page seems expensive for that, but if we have enough other things for which a per task page becomes useful, then it might start to look less of a luxury. And this does actually seem to work. The ideal test would do all kinds of horrible, low-level, non-portable things. I'll leave it to for people to decide whether systemd ticks that box or not. So far, I haven't seen anything I've run in user space go wrong with this mechanism enabled. And the overhead is much reduced compared with the setcomp case. The base overhead of getting in and out of the kernel increases by something like, theoretically, it should increase by 2 times because we trap into the kernel, we leave again to enter the VDSO, and then we enter the VDSO a second time to return, which we might not need on all architectures. When I tested this, I actually saw the overhead quadrupling, and I haven't got to the bottom of that yet. That may be some platform-specific issue. But either way, that's just the overhead of the system call and doesn't include any of the actual system call implementation. So if your killer use case is calling get PID in a tight loop, then you'll see some increase in cost, but otherwise it shouldn't be quite as bad. This doesn't mean that adding cost to any hot path is a great idea, but the important point here is that only legacy binaries that are making syscalls directly would experience these bounces. So those would make the syscall, it bounces to user space, the VDSO does something, and then we call back into the kernel. To avoid that happening, you need to port software that makes direct system calls, but that's not all software. It's typically just C libraries and compiler support stuff, language runtimes and that sort of thing. I didn't try to enumerate all the cases, but it's certainly much less than all software. And software that's been ported would then avoid that extra overhead. They'd just call the VDSO, and then that might do a real system call, or it possibly won't enter the kernel at all if that's feasible, in which case it would be cheaper still. Unported software should still work, though.
It seems to me that there's a way to avoid the need to port as well, which is simply to have the syscall entry code arranged to call the bounce page only if this is a syscall that would otherwise return enosys. So only to make to move one of these legacy syscalls out, you'd rip it out of the kernel syscall page, which would cause it to bounce, and then have the VDSO check: is this one of the syscalls we implement? And if it doesn't, it would throw an enosys back out. That way, you'd only bounce for obscure things like personality, which are hardly ever called anyway. So who cares if it takes 4 times longer?
So the first path by which we get into the VDSO at all, that's a bounce, and that involves going through the kernel, and it's not obvious to me how we avoid that.
As soon as you go into the kernel, I'm assuming here that that the normal raw syscall entry path for syscalls we're not planning to rip out would remain.
Yes.
You wouldn't bounce everything back out, every syscall back out, only the legacy ones. It's only one bitmask check, really, isn't it?
So the way I've...
need to do that. All you need is, all you would need is for the syscall table to, all you would need to do in that case is for the, that entry in the syscall table to point to the reflection routine.
Yeah.
So you actually end up with 0 overhead. However, I'm gonna be at a later point. I'm gonna throw some more cold water at you.
That was kind of the point. So, yes, you're quite right. The way I've currently done things, all direct system calls that don't come from the VDSO are bounced back out. So then you can do absolutely anything you like in user space, but that does add extra cost. And yes, another option would be that's actually selective in the kernel rather than being done for all system call numbers. So there are still some things that can go wrong. It's difficult to hide this mechanism completely from user space, so creative user space software writers might find ways of depending on the details of this. Certainly we wouldn't encourage it, but it's not clear how much this matters. User space can do other things which may mess this up, like unmapping or moving the VDSO. And some interesting things that can happen there. If you're in the middle of one of these bounces and another thread unmaps the VDSO or moves it. Perhaps that's just user space shooting itself in the foot, and maybe it doesn't matter, but it certainly needs thinking about. Static binaries is another case that came up. Classically, static binaries don't use shared libraries. That's sort of the point. There's no underlying technical reason why a static binary can't parse the VDSO and find entry points in there and call them. But it's not something that everybody should implement longhand. Can you pass the microphone back?
So on 386, we actually have, specifically on the 32-bit, we actually have a solution for this, which is that there is a generic entry point that is equivalent to a system call that is exposed through a different, it's exposed explicitly.
A separate entry for that, isn't there?
Yeah, so you don't need to do a full parsing of the dynamic structure. You can just call that entry point and have instead of executing an int 80 instruction.
Yeah. Obviously, if you wanted to move in the direction of having, say, a per system call entry point in the VDSO, that doesn't work directly, because then you might have a separate entry point for read, for write,
you
for whatever.
You could equivalently point to a table.
Yeah, you could obviously do that. So there's different options here.
You could even just have a generic, like in that VDSO, have some code that simply just checks for your number and jumps to the right thing. I mean,
yeah.
You don't have to. The problem is when you expose tables as data structures to the outside, you always cap yourself into boxes, sizes and such, right?
The other option is that you simply parse the ELF object and look up the symbols, which is slightly painful to do yourself. If I hack something up, it's like, I don't know, 50 to 100 lines of code. I probably don't handle all the cases I should handle.
Well, that's actually what we do. That's actually what we do now.
Yeah.
You have to get your symbols out of the dynamic section.
Yeah. Ideally, the C library does that, and you don't have to care. But however it works.
But it is. You don't need a full-blown. You don't need a full-blown linker to do that.
Sure, and that was kind of my point here. To make it clear that this doesn't break static binaries. There are other places where this behavior will be observable, like ptrace, where the way I hook this in, system calls that we bounce don't appear in ptrace at all. So it looks like user space has jumped to another location, and then ptrace sees the syscall made by the VDSO instead. That's certainly different. It's not obvious whether that's wrong behavior or not. There may be other policies we could use there. Some other things expose syscall internals as well. So there've been a number of discussions about seccomp this week. ftrace also exposes what system calls are happening and so on. The syscall interface does evolve over time, so any software using those does have to cope with things changing. But exactly where you draw the line between what's an acceptable rate of change and what's gratuitous, I don't know. That would be interesting to discuss. If this can all be made to work, though, what might we be able to do? Well, there are certainly some things that might be removable from the kernel altogether, so personality and set get robust list, do little more than access a variable. If we have a suitable user page to store that in, we might just have the user library do those directly with no entry into the kernel. Some PLCTL commands might be amenable to a similar implementation. I haven't investigated that in detail yet. We might need different pages for things that are shared between different groups of tasks. So UMask, the UMask, for example, is a property of the group of threads sharing a file system context. Having a whole page for that would obviously be kind of expensive. It largely depends on whether there are other things that we can put in there, whether it seems reasonable. A file system context, at least there's generally only one per user space process, so it's not quite as bad as having one per thread. Where system calls in the kernel have been superseded by newer ones that provide richer functionality, we might be able to just move all the glue for those out of the privileged kernel and have those done through user space wrappers instead. Another thing that I thought would be fun to investigate is whether you could move some of the signal delivery machinery and maybe the signal mask out to be stored in user space. That's certainly not trivial in all aspects, and it might be impossible in some areas. But yeah, it could be interesting to hack on. And ultimately, we could maybe define the kernel interface as a set of functions which we expose through a library instead of a binary interface. And that potentially gives us a lot more freedom to redesign how those calls work across the unprivileged privileged boundary between kernel versions. Another thing that we don't currently, we manage in a sort of ad hoc way is versioning of this interface, and binary formats such as ELF do provide some facilities to describe different versions of functions and so on. So you can, for example, with ELF symbol versioning, you can make incompatible changes to functions without the need to define new function names all the time. Software linked against an older version of the library will carry on using the old version of that function, which supports the old interface. This isn't that we can do the same thing in an ad hoc way, of course, but yeah, this might create different possibilities. To do all of that would obviously be a pretty big project, but you could do parts of it, you could do things incrementally. And that is about as far as I got. So, yeah. If somebody wants to shoot down the idea, as I think they do.
Okay, so I am going to throw something really, really ugly at you. And that is, in some ways, you've solved the easy part of the problem. Or, attempted to solve the easy part of the problem. The part where we have real issues with backward compatibility are things like IOCTLs. And first of all, you literally can't know what an IOCTL, where an IOCTL is destined. Although in Linux we try to not reuse IOCTL numbers, In practice, they are driver specific, and so so the real issue there is the marshalling of data structures in the memory, and that can require an unbounded amount of memory. So you would have to have, basically, you either have to have an unlimited stack, which we generally don't have, especially not in a multi-threaded application, or you would have to have your fallback code call malloc. And that, all of that has some very, very messy consequences. The other thing, now, the good part is I like the idea that you have about being able to do more things than we currently do in user space. Like right now we do a few system calls. Most architectures can do a handful of system calls entirely in user space, but as you said, there might be additional things that we could do by having non-global data in user space, and that's very interesting. Now, a user space library that is just a user space library, not a VDSO, could reduce this problem without completely turning it upside down. And the way it could reduce that problem is that we already have configuration options in the kernel to cut out certain legacy code. And if you don't do checkpoint restore, then or even if you do checkpoint restore, you have it can be a user option or a distribution option to gradually remove these legacy calls and have them go through but then you have to go through a user space library.
Yeah. So your view is that library would, if you say migrate using Cryo to another host, you would migrate the library. You wouldn't attempt to use a different library.
Yeah, so we already have, I think, 4 other questions queued up, and we don't have that much time, so if questioners could keep their questions a bit succinct, that'd be nice for everyone.
So it's about the signal mask in user space part that you said. Come to talk to me if you want to do this, because restartable sequences registers a thread local storage, and I have ideas on how to do it on a per thread basis.
Okay. Yeah. What about restartable sequences was something somebody else asked me previously, and I haven't fully dug into it. So,
another big roadblock for this is POSIX thread cancellation. I don't think you can reliably implement it over this scheme.
So you mean if the thread is cancelled while we're in the middle of one of these things, or?
Yeah, especially if this VDSO code invokes several syscalls, because you wouldn't be able to tell whether some resources have been actually allocated or not. So that kind of problems arise.
Yeah, I guess that would place some constraints on how you implement those things. Some things you might be able to implement in a cancellation safe way so that it doesn't matter, but if there were multiple system calls involved, yeah, I guess you're right, it could be difficult.
And even if it was just a single syscall, how would you know whether it has allocated some resources or not? If
that's a good point.
Can't control this.
I don't have an answer.
How would you handle NoMMU, where you might not be able to have a VDSO?
So the VDSO is a thing that's visible in memory somewhere. Does NoMMU prevent that? I don't really see that it would.
Well, you'd have to have endless copies of it, well, a copy of it per task, potentially. And if you've got a static binary, you may not be able to relocate it.
So I don't have a lot of experience with NoMMU, but is there anything to stop
Well, if you've got data in there, because you talked about storing the UMask in it or something, you'd have to have many copies of it. But you could probably do it with FDPIC, but I'm not sure you could do it with flat.
So for handling things like the per task data page, to avoid having a separate for every thread, which you really don't want, you could pass the pointer to that page into the handler in the VDSO, and I guess that should work with NoMMU as well. So you pass a different address in depending on which task you're running. Would that work?
So one thing that strikes me is that the compat layer, the compat system call layer we have in Linux does just a lot of argument shuffling, and it sometimes does it on the user space stack anyway. How much of the compat layer do you think you could implement with this, and would it solve ILP32 for ARM64?
So part of the problem with the compat layer is it requires you to convert like 32-bit arguments to 64-bit and so on, and we can't do that in 32-bit user space because we're 32-bit there. There are probably some things you can do, but yeah, I haven't completely thought about it. Other types of ABI kludge layer where you're at least using the same ISA may be doable, but you would need information about argument types and so on. So I think we're about to run out of time.
So I'm going to make a comment on the last thing. There is one single reason why we added a bit in the X32 ABIs to know that you're using an X32 system call, and that was that there's a file in sysfs in the input layer, the format of which depends on if you are it depends on if you are in the 32 or a 64-bit process. It will literally print out in ASCII text versions of numbers that are the size of long in user space. And this is exposed through the normal file I/O system calls. It's not an IOCTL. This was the one reason we had to track that into the deep layers.
That sounds fun.
All right.
Okay, thank you, everyone.
Yeah, we're about out of time. Thanks for that. Yeah, I'm sure we're going to have lots more discussions about this on mailing lists. So, all right, thanks again.
And download the slide deck and follow the links if you want to have a look at some terrible code.
You all set? Okay, great. Okay, if folks could take a seat if they're going to be sticking around. All right. Next up is Brendan Higgins, who's going to be talking about K-Unit.
Yep. Need to present. Yeah, so as Ted said, my name is Brendan. I work at Google. I used to work on server bring up at Google, and I also used to work on OpenBMC, if anybody knows what that is. Right now I'm spending all my time working on KUnit, because it actually turns out it's taking a lot more effort than I thought it would. So, yeah. So first off, I wanted to make sure I remembered to say this. Please interrupt me. This talk is for you. I already know what it like about KUnit and stuff, so I would much rather talk about what the audience wants to talk about rather than what I think that you want to talk about. So I also really, really hate slide decks. Like, I hate the concept of slide decks. So by definition, I think my slide decks aren't very good because I don't think you can make good slide decks. So anyway, don't read into that too far. So yeah, so why unit testing? Why KUnit? So I think it's demo time because I think it's best to just let it speak for itself. So, oh, this is fun. I just realized. So I can't, for some reason, mirror my displays. So I'm going to have to let's see. Okay. Okay, there we go. Cool. So I'm going to have to look at, where'd my mouse go? There we go. I'm going to have to look at the monitor on here, so that's going to be fun. Okay, so all this is I checked out Shua's for next branch. So the code that's here is going to be available like upstream whenever Shua's branch gets pulled into Linux mainline.
Can you put the font up, maybe?
Oh, yeah. Let's see.
So the people in the third row can actually see it.
Is this good? Can everyone read this? Yes, more? You want to be bigger? Okay, cool. So the only modification I did is I intentionally went in and broke some code, so that way you can see what a test failure looks like. But other than that, this is just what's in Shua's Linux Next. So you can run KUnit like this. I added some extra parameters for setting a timeout and for making it. Oops! I unbroke the test. Oh wow! So I ran through this ahead of time, and I wanted to make sure that I did this. So okay, I'm going to break it on my side. So yeah, I didn't actually save it in Git. So I'm just going to break it. You won't be able to see me break it, and you'll just have to trust that. Okay. So I guess this is what happens when I kind of asked for this. Yeah. Okay. So this should fail now. Yes, fails. Okay, cool. So, okay, I can't. There we go. We can scroll. Okay, so this is what a failure looks like. You have an expectation failed at this line. So I'm going to open up this file. Oh wow, dexterity trying to do on looking sideways. Okay. Oh, need to do vim-p. And then, so naming convention I've been trying to promote is it tests a thing. So if you have a unit test profile, then it's going to test that thing, and then the unit test will be that name -test. So in this case, the syscall test tests syscontrol just CTL. There we go. Cool. So So if we went back there, it tested line, I think, what was it, 363? 368. 68. So we see that there's an expectation here. It calls this function proc do intvec and expects it to return an e intval. So we know that we're looking for an errno to be returned by this, and it's returning the long one. If we go back to the example, we saw that the number that was printing it out corresponds to eRange. So we can just look for eRange here. And I had already opened it to that line because I intentionally broke it. So that'd be L. Okay. And if I run the test again, it should pass now. Yeah, cool. So that worked out. Oh, now I need to get rid of this. Let's go. Okay, there it is. Close that. Sweet. Okay, so I did also record a video just in case my demo didn't work, but I just do basically the same thing except in a slightly more organized fashion without as much mumbling. So how's it different from the testing we already have? I think the first thing is it's pretty fast. Unlike my demo, the tests run pretty fast. All you have, like, right now they're pretty much bound by how fast you can build the kernel. It doesn't depend on user land. I think that was pretty obvious. Hopefully it's sort of obvious. And it doesn't have any external dependencies, and writing a test is no different than writing any regular kernel code because the actual test links against the code that's under test. So I think that makes it pretty convenient. It means that you can just test like arbitrary functions in the kernel. So in other words, it's unit testing. So I debated on including the next section because I don't really want to get up here and preach about like unit testing and like how unit testing is different from other things. I think that if like people want to understand like the reasoning behind like why I made some of the decisions that I did, it's probably important to understand. I don't know, you know, there's different philosophies for testing, but it would be important to understand my philosophy of testing, of what unit tests are. So do people want to hear about that, or do we want to move on to something else? Yeah, hear about it? Okay, we'll talk about it. Yeah, so I think, so the way I like to break down testing, and there's a lot of tests that fit outside of this testing category or testing regime, whatever, but I'm just going to say tests can be broken down into either unit tests, integration tests, or end-to-end tests. So I'm going to start off with, do people already feel like they're, like, how many people here feel like you know the difference between a unit test, an integration test, and an end-to-end test? Can you raise your hand? Okay, that's most people. So, huh? Yeah, so maybe we should just move on. So I'll just run through it really quick then. So an end-to-end test, the point is you're supposed to test the entire system under test. From the standpoint of the kernel, I don't think this necessarily means like, you could argue that would be just in testing like an entire application that you have. I think from the standpoint of the kernel, this means you actually boot a real kernel on a real machine, you have some user land programs which directly interact with the kernel, and then you test it that way. You're supposed to be trying to emulate what it would look like for a user of your system. So I have an example here of you might want to do this by, like I said, just running on production hardware and then trying to exercise some behavior that depends on the hardware, the kernel, and then like the syscall interface you provide. The idea is you're trying to keep it as close to the production like environment as possible. A unit test is supposed to test things in isolation. So the idea is you're exchanging the realism for determinism and hermeticity. So your tests should be a lot more predictable. They should be a lot faster and easier to understand, and it's a lot easier to write them and maintain them. They should be very, very fast, and they shouldn't require any kind of setup. Like when I say fast, I mean your test should run on the orders of milliseconds. So yeah. And an integration test, the way I think of it is it's just something that's in between a unit test and an end-to-end test. It does test the interaction between things under certain circumstances. You could write a hardware integration test that just tests how a driver interacts with its hardware. But at the same time, you're still trying to keep it as simple as possible. It's not necessarily going to be a realistic environment, et cetera, et cetera. So I have a little Punnett square thing here that compares the different things. So basically, unit tests and end-to-end tests are just kind of opposite. The scope for a unit test is very small, which means that in terms of overall coverage, I should have probably specified that the overall coverage you can achieve with all of your unit tests is quite high because you can test functions directly. But the amount of coverage for an individual unit test is going to be quite low because you're just testing a single unit. They're going to be really fast. You should have a really high confidence in the individual thing that you're testing, but that also means that you have very low confidence in like the overall system. End-to-end tests are the opposite, and an integration test is just a trade-off. So K-unit's not a new idea. Lots of other people already use unit testing. There's lots of other really, really good examples of unit testing libraries out there. In what I've put in what is staged in Linux Next, there really aren't any super new original ideas out there. It's all stuff that exists. So I don't think I should be awarded for any kind of cleverness in K-unit. It's really just about if I deserve any praise for anything, it's just because of the will that's taken to do it. Yeah, so I don't really want to talk about the XUnit stuff. We already looked at an example. If you want to learn more about XUnit stuff, there's this really good Martin Fowler article on it. I guess I didn't actually define the term XUnit. Do people feel like they know what XUnit is? Yes? Raise your hand. OK, so that's actually no. So XUnit is basically just it's a really popular style, a framework for writing unit tests. Basically, you have like some setup code that runs before every single test case. You have a collection of test cases. And then after every test case, you have some cleanup code that you would like to run after every single test case. And it just makes it easier for you to do that. That's the kind of pattern that I followed with K-unit. I have I have an example of that we can look at if anyone wants to see it, but I think it's pretty self-explanatory. So where's K-unit today? The initial patch set, which includes the ability to define unit tests, along with individual test cases, and like I mentioned, the setup and teardown logic, expectations and assertions, which give you the ability to actually like define the behavior that you would like the code under test to exhibit. Assertions are just an expectation that allows you to bail out a test quickly and easily. There's a resource management API, so basically, if you want to unit test some code, you're probably going to want to use resources from other parts of the kernel in your part of your tests. So it makes it really easy to use resources and not have to care about it. The test case will just clean it up for you. And there's also some tests. So, oh yeah, and also I think the thing that I showed in the example, the really pretty like colors, there's a test that extracts the K-unit results from the kernel. The results are kernel readable, or human readable in the dmessage log, and there's a tool that makes it really easy to, like it parses them out and then displays them in pretty colors. So that's what's up there today. There's a bunch of other things I'm planning on doing, but I'll get to that later. Challenges I faced in trying to do this. The main challenge is probably kind of obvious. The Linux kernel wasn't written intending to be unit tested. Actually, the code was pretty good for the most part. I've not found that many instances. Like I feel like most of the code in the kernel actually lends itself to unit testing pretty well. The Linux kernel code actually exhibits a pretty high degree of encapsulation, code sharing, and modularity. And it's pretty actually object-oriented, especially in a lot of parts of like the driver stuff. So It's actually pretty easy for the most part to find lots of parts of the kernel that are already written well from the standpoint of making it unit testable. The biggest problem is that dependencies are poorly defined between different code modules. So if you want to take a piece of code and unit test it, you still want to be able to take all the things that it depends on, but not include every single thing else. And so right now, that means that I have to still build the KUnit test into a kernel to provide all the resources that an individual test actually needs to run. It'd be a lot easier if it was a lot easier and a lot nicer, a lot more hermetic, if we were able to just take the things that we need to run the test, that the test actually depends on. The main problem I found with this is that kbuild represents dependencies in terms of features and not actual code dependencies. Like, it's hard to look at a piece of code and say, this piece of code depends on these functions, which are defined in these files. If you look at the kbuild, or the associated kconfigs, which is where the dependencies are defined, you see that some feature depends on some feature, and it's not really there's not really an easy way to map those things out. Does that make sense? Yeah. So, as far as where we fit in the test paradigm, this is probably pretty obvious. We already have lots of examples of different types of end-to-end tests, and I don't want to get like too into this. A lot of the traditional definitions of an end-to-end test, or of unit test, integration test, and end-to-end test are based on how much the code knows about the code that's under test. And from this standpoint, you could actually argue that some of these testing frameworks aren't strictly end-to-end tests. I don't want to debate that too much. I think that based on the criteria I defined here, they look a lot more like end-to-end tests for the most part. You do have to boot a kernel somewhere. You are mostly interacting with the code through a syscall interface. I mean, I think if we're going to try to like stick it in one of these three categories, we'd say most of the things that are there are end-to-end tests. I think that KUnit does a pretty good job of fitting the definition of a unit test. And even though there's definitely some overlap between what KUnit can do, what things like kself-test can do, and the area of integration tests, I don't think there's really like a clear thing that currently exists for doing the integration testing part. So I think that's something that probably needs further thought. Please feel free to disagree. Yeah? Sure.
So I'm not disagreeing, but I'm just adding to it. K-self-test kind of will fall into because of the way there are some modules you can load and trigger tests. So it's a bunch of binaries and shell scripts. Mm-hmm. I would classify that as a combination of black box and white box.
Right.
There is some unit tests in there. Mm-hmm. There are some end-to-end tests. And like triggering, going and exercising various syscall options, for example. Mm-hmm. So those kind of fall into the category of black box test that's written by developers, right? So you kind of have to do that distance. So they have that, they know what they're testing, they want to test. And in that respect, it's not strictly black box because whoever is test author knows the code. Right. So in that respect, it's not strictly black box, in my opinion, but black box with knowledge of the internals, of how the actual code testing. So it falls into that category. So anyway, just a clarification that it falls into that. Yeah. So we do need to. You're right. We do need to figure out with the KUnit in there. We need to kind of figure out to have a better story, how we can increase coverage using both.
That's a good point, and so that's like part of why I actually didn't include that in my definitions of what a unit test and integration test and end-to-end test was, is because I didn't want to get hung up on like the white box, black box part. But I think that's true. So I think there's definitely cases where you will find appropriate integration testing coverage provided by either K-self-test or KUnit. I mean, for example, KUnit can run on, it should be able to run on all architectures. I've tested it on ARM and x86 and of course UML. So it should run on all architectures, which means you should be able to use it for hardware integration testing. Nevertheless, KUnit is not currently capable of doing user space integration testing. And so there's elements of integration testing in both of them. And I think that's partly just due to the nature of integration tests are kind of the in-between thing. But I don't think there is a well-defined story for if you want to be doing that kind of testing, like what the procedure should be. So I think that's probably something that needs more thought. What are we planning to do in the future? So I need to improve documentation. I think what I have there is pretty good, but it's also clear to me based on some people who've used it, I've talked to them, I need more documentation. So I also have, in the original, I think it was the first version of the RFC, I had some mocking and faking stuff. So that way you could like fake out hardware or mock arbitrary like functions or like driver classes. I'm planning on getting those out at some point. I've not really decided how to prioritize that. That's partly why I'm talking to you now, is I'm hoping I want to see what people are interested in, how I should prioritize things. It's pretty clear that I need to work on the test result parsing. There are still some certain cases of demessage logs from the kernel that it doesn't parse. It's pretty straightforward to fix, but the main thing is right now the scripts I provided assume that you're building and running the kernel with UML. It should, I know a lot of people out there want to build and run all their tests on QEMU, and some people have to use them on hardware for various reasons. So I would like to split out the parser so that way you could take your own demessage log from wherever you get it and parse that and get like nice test results for it. Let's see. We need to figure out CI/CD for KUnit. Yeah, I think that's mostly self-explanatory. Things I'm planning on focusing in the near term, if nobody gives me any additional input. Yes, Tim? Yeah.
Is there any plan? I thought the first versions of this emitted KTAP.
Yes.
So it didn't look like KTAP.
What? Oh, right. Yeah. Okay. I'll move my terminal over and we can. Okay. So this is the wrong directory. Nope.
Do you want the font size?
Oh, yeah. Oops. Good? Okay, so if we just run the kernel by itself, oops. Yeah, this is what it actually prints out into the demessage log. Yeah, so yeah, it does support tap. So there are some minor things that aren't really tap conformant. Oh, well, you can't see it here because if all the tests pass, it actually is. Expectations are multi-line and it doesn't, so if you see like the directive thing, anything that is a like message coming from the test is supposed to be prefixed with the pound sign. The subsequent lines of the expectation don't have that. Technically, looking at the TAP standard, if I wanted to put according to the TAP specification, the expectation results should actually be added as a JSON payload.
Yeah, well, my opinion has shifted on that. I think we had to ignore the TAP specification, and
Okay.
I don't know if you noticed, but I called it KTAP because I think we should just come up with a output format that works for us and do whatever is handy for our own CI systems.
Okay.
So,
Well, then we need to decide how to represent something like that.
right. But we need to have those discussions. So.
Yeah, because otherwise I need to add a JSON serializer to the Linux kernel.
Yeah,
That's
let's not
going to be
do
really
that.
popular.
So Tim, are you saying we want to rip out all the TAP stuff that you made me add to K-self-test?
I want to augment it for kernel specific.
Okay.
Let's talk. Yeah, let's talk.
Yeah.
Sorry.
Yeah.
I have a couple of feature requests actually. So we might make use of KUnit for dynamic tools like KSN and KMSN. For that, we probably need to somehow capture the DMESC output because the tools are printing error reports, and we want, for example, to check that they are printing good reports, that everything is contained, and that we detect the errors, etc. So this would be handy. And the other thing, does KUnit support anything like death tests in gtest?
So that's a feature I have on the way. It's not fully implemented, but it's able to handle seg faults. But it looks like it should be extensible under UML to also handle panics, which is probably the more interesting use case. Trying to do that on arbitrary architectures would be harder. But anyway, so yes, sort of. It's not currently in there, but it's something I'm going to be working on.
I see. Okay, and sometimes our tests tend to corrupt the memory, for example, which is why we're testing it. But it could be nice to somehow fall back to the good state.
Yeah, so this is kind of gets back into what I was saying about like kbuild and kconfig. It would be nice to just include the things that you need, which I don't know, maybe from your perspective that may not be true. But if you depend on less code, less non-test code, then that means it's a more hermetic test because there's fewer things that can go wrong. I mean, I guess you could argue that with those other things that if they're not actually being used in the test, then they don't matter. But in any case, for the short term, I'm planning on adding a feature to the script, that test running script, that allows you to boot the same kernel containing multiple tests multiple times, and each time run a different selection of tests, which should create a higher degree of hermeticity. So at least one failing test suite should not affect another failing test suite. Does that sound kind of what you want?
Yeah, probably.
Okay, cool.
Thanks.
Yeah. Anyone else? Yes.
So many of these features and issues are already solved in other unit test frameworks. So why not work on adapting an existing C unit test framework instead of KUnit?
Yeah, I thought about that.
We all think the problems we're solving are unique, but they rarely are.
Yeah, no, the problems really aren't that unique. So the main reason is, so I looked at something like, I looked at some of the testing frameworks that are out there, and they're rather large and are rather unconcerned with the kinds of things that the Linux kernel is doing. Not from the standpoint of just testing arbitrary code, but like kernel standards and such. I felt that so one of the things I thought was really important is making, all the tests should be written in kernel C that compiles against the kernel, and the test should be in a visible location. Like, I think that the test should live alongside the code that they do test. And I imagine I figured it would be a lot more difficult to try to just convince people to start following like conventions from another testing framework rather than have something that the Linux kernel community can have input on. For example, a lot of other unit testing frameworks assume that they have their own, like, they get to define like expect EQ and things like that. They assume that like everyone's just going to respect the fact that they get to run in the global namespace. And that was pretty much the first thing that everyone's like, no, everything needs to be like properly namespaced. So it just seemed as though it would be a lot easier to engineer around the problem of getting people to buy into changing conventions and stuff. Does that answer your question?
Yeah, I think so. It just seems like there should be some kind of partnership or reuse with someone who's solved some of these problems already, even if it's not just adapt their whole framework.
Yeah. That seemed a lot harder, so. But, I mean, if you want to do it, I won't be opposed.
Accepting pull requests?
Yeah. So, yeah. So in the near term, things I'm planning on working on, hopefully getting more people to write tests, improving documentation, as I mentioned, making the things that are already there easier to use. A couple of people have pointed out things about like the test script that I have that are not perfect. Adding tests, getting people to write more tests. And I'm thinking in terms of large features, 2 maybe big areas are working on this matchers API, which is basically something they're like these composable matchers. Has anyone used, what is it called? Expect that. I think it's now in JUnit, but it was originally part of something else. Is anyone familiar with that? Okay, whatever. The main thing it was originally written for was for parameter matching. For if you have like a mock stub and you'd like to set an expectation on how the mock stub is used, you can use these like matchers in place of parameters to make assertions about how the parameters are passed into this function. After looking at a test that was written recently, it seems as though it might make sense to have it as a standalone thing and not be strictly used just for parameter matching. So maybe that, maybe just mocking. But I mean, it's what people think is most interesting. Yeah, we still have, I think, a decent amount of time, not 15 minutes.
Okay, so I had some input on the K-build and dependency thingy.
Yeah.
At least in the DRM subsystem, we are moving more and more to helper libraries.
Okay.
And these helper libraries, we express them with a hidden kconfig option, basically, and everything which needs that kconfig option selects it, instead of depends on.
Yeah.
And I think that if you were to do that for more stuff which you want to unit test, so if all the base things were sort of becoming libraries at a kconfig level which you would select when you need it, then you are more expressing what you want, basically. And in general, this solves a lot of things like dependency cycles and stuff, so this would be something, work which would be more, not only beneficial for the unit testing, but also... Okay,
that sounds interesting. Yeah, what's your name?
Hans de Goede.
Hans de Goede?
Yes.
Could we maybe talk afterwards? Sure. That sounds interesting. Sure. I mean, yeah, Ts'o?
That flows in. I was going to point out that config option dependencies that on your next slide, next steps. If you can go to the next one. Yeah, on that, I would add reporting and then config. Reporting test results, like
like CI/CD.
Right.
Yeah.
So and then also also the config dependencies, and then so that's probably where we'll be spending a lot of time based on my experience with K-self-test, getting it to be usable in CI environments. I don't know that if this will be used, but something to keep thinking about. We might need a unified approach. Distros want to run some of the tests. They're coming and saying which tests should we run for distro qualification. So we might have to approach this as a unified thing to come up with so we're not. We don't have like multiple different ways for each suite. So something that.
Yeah, I think that. Like doing something along the lines of K self-test fragments. Unfortunately, it seems like some of the.
I'm looking for a specific way to do it. This is something that we have to.
Yeah. Sure. Yeah.
Capture that as something that
okay.
We
Okay, sure. Yeah.
Yeah, this might be related. Do you have a way, like say I want to write a test and I want to test it with big endian and little endian, or, you know, I assume at the moment you just build one config?
So you're free to build the test with different configs.
But that's sort of external.
Yeah, that's external. That's something you'd have to do.
It would be cool if you could sort of have that next to the test. Like,
yeah, there's some other things like that.
I realize
like,
that's super hard, but.
Yeah. There's some other things like that. Like it would also be really nice if you could specify the original use case was for driver testing, because I used to primarily work on drivers, and it would be really nice to be able to specify, like when you're probing a driver, you want to probe a driver in a particular way. If you could just specify a set, write basically a device tree fragment and say I would like to probe with this device tree fragment. It would be nice if you could do that in a test. And I think that's a similar kind of thing.
Yeah, I mean it's kind of test data or something.
Yeah.
But but because of the way it's done, you have to actually do it at build time with the config stuff.
Yeah, which is difficult because you need to know about the test, which happens after config time, and then use that to configure things. So it's even harder. Yeah.
I mean, you could sort of have the configs the test cares about somehow and suck them out and build multiple kernels with those toggled and come up with a
do like multiple passes on the build phase.
Yeah. Sort of an extension problem.
Yeah, I was going to add that one of the things that we did with XFS tests was we would actually, after we were done running the test suite, create a test artifact tar.gz that would have the kconfig, all of the test artifacts, including dmessage output, so that after you could review the pass-fail thing, which might be running somewhere far away from your development system, you could fetch that test artifact and do the in-depth debugging. And I suspect that having something like that, which was standardized across all the various test infrastructures, might be kind of handy. And that's sort of related to that is one of my dreams, which is at the moment, we kind of assume the CI tool actually handles collecting all the test results and listing them all. And the problem with that is that assumes that all the tests are running inside the one true CI system. And if you have lots of people running your test suites in their own system, some sort of way of collecting that all, and maybe even from disparate test systems, and then being able to collect it in some standard format might be really useful. Right? I mean, I actually have my stuff going out in JUnit XML format. So in theory, that could get consumed by some central system with a back pointer to where you could actually download the test artifact if you actually cared. I think that's maybe one of those interesting things. That's not a KUnit specific thing, but just how do we integrate all of our various testing systems in some bigger, way of detecting flakes and test failures and whatnot.
I think Tim has a comment. So I think we actually talked about this the other night at, were you at the CI BOF? It was like we talked about kernel CI and KCI. So I think we talked about this there, and I think we all agreed that would be a nice thing to do, but I think the TLDR is that's also really hard.
Yeah, work has begun. Work has begun on that. In fact, I have a presentation I'm giving at the CKI HalfX tomorrow about consolidation of test definitions, and I have a couple of slides because I have things ahead of it, but a couple of slides on results formats, standards, and in other presentations I've given at other events. Also the notion of packaging results, and we had a discussion yesterday in the BOF about a centralized location for storing artifacts. So stuff is happening, but it's happening relatively slowly, but hopefully we'll make some progress.
Cool. Frank?
I've moved on to my tests are now end-to-end tests, now that I see your definitions. One of the point we talked many months ago about dependency on the scripts that you have to run the test. And when I run on real hardware as opposed to UML, my real hardware is scripted in my systems. Each different piece of hardware has different boot methods, loading kernels, etc. So it's important to keep the booting a system running the test separate from, or able to pull it out from your generic script. So your script includes creating the system, booting the system, getting the result, analyzing the result. It'd be real nice if the analyzing the result is also available in a standalone form.
Yeah.
So when in my infrastructure, I'll have a log which I can run through that same nice formatting out system.
Yeah, that's one of my to-dos. Bjorn also wanted something similar because, yeah, this doesn't really work if you need to run in QEMU or on real hardware. So it's definitely a to-do. That's what I meant by splitting out the parser thing. Yeah. Is there anything else?
Other questions?
Yes.
My pitch again on industry standards, but if the comment about some of the common results and like the JUnit XML was kind of interesting, because if you know, the parser has an option to spew it out in some format that other frameworks are commonly using in totally different communities, and we could take advantage of other tools for generating analysis and whatever other types of things other people are doing too, because it seems like the people in this community should be focused on solving the problems here, not repeating the problems that everyone else has already solved.
Yeah, that's probably true. Okay.
Any last questions? We're just about out of time, but I think we have time for one last question. All right. Cool. Okay.
Right.
Let's thank Brendan.
Hello, my name is Dmitry, and I wanted to share some of my thoughts on some aspects of the kernel. So first of all, who am I? We started working on user space, sanitizers, fuzzing, hardening, and about approximately 5 years ago, we thought maybe some of those tools may be useful for kernel. I'm not the most active developer in the kernel. I contributed to some of the debugging tools, did some fixes. You may also know me because of the syscaller and sysbot, so I manually reported more than 500 bugs, and then sysbot reported more than 2,000. So, and this gave me a quite unique perspective on some of the aspects of the kernel. And when I started working on the kernel, I started noticing things, and things that looked kind of wrong. And those can be roughly qualified to two buckets. One is related to bugs, quality, security, and testing, and the second one is development process, tooling, experience, satisfaction. So bugs. Whatever way you look at this, there are just too many, right? The fixes stacks, we have 9,000 per year, which is a significant % of commits, and we know that less than half of fixes actually have those stacks, so it's actually more. And sysbot reported several thousands of bugs, several bugs each day. And actually, the thing is that fuzzing was not supposed to find that many. It's not supposed to find simple bugs and completely broken subsystems. And we'll still cover only a small part of the kernel, and we are finding only crashes. So we don't actually do any logical check-ins. So we don't do testing in this sense. And we still don't detect some classes of bugs. So it's also not a complete number. And now it's not getting better over time. We kind of have roughly consistent flow of bugs over 2 years. And also collected a number of very interesting bug stories. How the whole subsystems in the kernel were broken for 4 releases, so more than 1.5 years. How subsystem became broken and stable. How critical vulnerabilities were introduced into stable. I've also seen people literally saying, I'm afraid that kernel developers will fix bugs because they will fix the bugs, but then they will break my functionality because nobody will run any tests. I've seen distro people saying that it's not possible for us to keep up or like monitor what happens in the stable just because there are too many things. And also Greg says that CVs don't work. So the useful process that works for other projects is not working for the kernel because we have that many bugs. The stable releases. So the stable is something that doesn't change frequently, right? So I looked at the number of changes actually in the stable. And for 4.9, it's more than 13,000. And 4.19 is kind of less, but if you look at the number of commits per month, it's actually now at almost at 400 per month.
I would like to say that stable doesn't mean that it's not changing much. I mean, it means that it doesn't crash. It's no bugs rather than no changes.
This is also a questionable statement. Okay. But so for 4.19, it's 700 per month. So it's literally, for the last years, it's literally 1 per hour. And we know that there are lots of not backported fixes. There is a number of bugs that are kind of known upstream and not yet fixed even upstream. And there are thousands of bugs that we didn't yet found upstream. So based on this, I can conclude that every kind of looks good and stable release we produce contains at least 20,000 bugs. And no, this is not OK, and it's not getting better, right? So if we would be fixing bugs just a little bit faster than we're introducing them, that we would be kind of at zero, right? So we're introducing them at this rate as well. And it's even worse. So as you know, nobody actually uses the kernel.org tree. Everybody has a fork, right? Each device typically has a fork. And for most practical purposes, each fork of a bug is effectively a new bug because somebody needs to backport the fix, review a fix, test the fix, and so on. So for example, at Google, we fix a bug in one kernel, and it doesn't magically fix it in all other. And how many are there? I think I can say at least 10,000. We're just looking at all of the devices out there. So if we multiply 10,000 bugs by 10,000 forks, it now gives us 100 million kind of bugs or work items we create for the industry every time we produce a kernel release, which doesn't look kind of good. So security suffers. Like lots of those bugs are exploitable. We see bugs, in the networking code, in the USB, KVM, and not even touching on the local access. The thing is that there's no consistent effort to ensure some kind of a base level of quality for almost any subsystem. There may be few exceptions, but generally it's not the case. And most of the work we are doing is mostly reactive, right? We get a bug, we fix it, but we don't even ensure that this bug will not reoccur next week. I'm not even saying kind of ensuring some area around this bug. And security usually requires very explicit proactive work. Yeah, so we need to fix lots of bugs, and people asking me like how we can make more of the sysbot bugs fixed, but not that I'm opposed, but unfortunately we're just fighting the consequences, right? The inflow of bugs is so high that we fix 5, but at that time 10 are being introduced. So until we reduce this inflow of bugs radically, fixing majority of the bugs is intractable, and tracking security issues is intractable, and producing stable releases is intractable. So this is for the bugs, for development process. Like patches are being lost, including patches for important bugs being lost for years. Patches are hard to apply because you don't even know the base tree for any patch. Patches are hard to send because you need to set up email, you get corrupted patches. Patches are hard to review because you don't have context, so you miss bugs on the error pass, which you simply don't see in the patch itself. You can look at the diff between versions of the change, and your comments are lost between versions, and so on. Bug reports also being routinely lost. There is no tracking of the review to the patch to the bug, and so on. And the transparency is not perfect. Like sometimes people don't know like who is going to take my patch. Sometimes it's taken by several people, and what is the status of my patch is kind of the eternal kernel question. And we also have different rules for different subsystems. Okay, and because of this, developer satisfaction may suffer. So it's kind of hard to quantify objectively, but when when your work is lost, or when you duplicate work with somebody else, or when you have to redo your work, or when you feel completely lost because you just don't understand what happens and like whose action is next on the patch. When you have to struggle with the tools, when you get late reverts of your commit, when you have inconsistencies, when you're effectively forced to break things and don't have a means to ensure that your functionality will not break next week. It kind of affect satisfaction. People may be asking themselves question if I want to send another patch which I strictly don't have to send. And lots of those can be directly attributed to the kernel process and the tooling. And developer productivity also suffers. Like all of the works on the bugs that could not be introduced, right, including debugging, fixing, review, apply, pull, backport, it could just not happen. Like, and fixing the same bug twice sometimes happen, or reporting the same bug twice, or when we lost a patch and then somebody needs to redo the work. And even spending time of such things as reviewing code formatting and basic style, it's something that people in other projects don't do today already. Also reposting your comments or trying to run tests or trying to understand if the test is passed or not. So I suspect that kernel developers could be like twice as productive if most of those would be addressed. And some of those problems may be partially neutralized if you for a long time in the kernel, you work mostly on a single subsystem, so you know the rules, you have some scripts, you know how to run tests, so it's became slightly better for you. But all of those problems are in full effect for newcomers, for drive-by fixes, when you're doing some work not in your home subsystem, when you're doing some cleanups or refactorings. And the thing is that we absolutely need all of those people, all of those fixes and contributions for the long-term health of the project. Yes, and most of those things are not rocket science today, like having pre-commit testing, tracking changes. Like lots of the projects are doing this today. You know how to do this. Okay, so this is kind of the problem statement. So then I try to understand why this is happening, what is the root cause. And initially I couldn't understand, because if you look around and like, is it that there is no test? And no, there are some tests and people start pointing you at different tests. Maybe there's no testing, it also false. There are several efforts for test the kernel. We have some tooling, we have Patchwork, Bugzilla, we have some processes. Maybe nobody cares, also not true. Like if you talk to somebody, everybody agree that those are the problems, we need to fix them. Maybe you simply don't have resources, and also false, because if you look around, I can count at least 50 people working on testing, tooling, static analysis, and other similar things. So we do have those resources. Maybe we just need to do some more incremental improvements at a few tests here, and do some few more improvements to Patchwork, and then everything will become perfect. It also doesn't feel that would be enough, right? So we can have all of the pieces that we need, but still yet it's all not kind of working for some reason. And then I started realizing that maybe the problem is the fragmentation. And by fragmentation, I mean multiple effort to do the same things, multiple solution to the same problem, lots of them kind of not isolated, not talking to each other. And the opposite of that would be consolidation. That's when we have single solution to a single problem, single effort to solve a single problem. So let's look how it affects testing, for example. So just if you're not in the area of testing, so testing is super hard. It's not just run the test. So so you start with onboarding test suites. That's a whole lot of work. People literally spend engineer years on this. And then enabling, deploying some debugging tools. That's also not simply flipping a config, and most of the CIs, for example, don't even have KSN enabled today. Then you need to build web interfaces, reporting by section, pre-commit testing, static analysis, make developers be able to reproduce your bugs outside of your CI, collect core dumps, and if you have hardware, that's a whole new set of problems that you have. And in the end, you just need to maintain this system and make it running, which is already kind of full-time job. And I'm not even touching on the kind of premium features like testing developer patches or producing coverage reports. So I can estimate it approximately maybe 50 engineer years doing like most of those things in some, basic form so that the testing is actually functioning. And which looks a lot, but the thing is that we already spent that many. We actually spent more than this. But the thing is that we spent it on like 7 assorted efforts. So all of them did lots of exactly the same things. Some of them did bisection, some of them still don't have bisection, and some of them have, say, better bisection, some have worse bisection, and doing something in one of them absolutely doesn't help the others. And this problem is hard enough to solve it even in a single copy, but trying to solve it 7 copies of it is just doomed to fail, and it's failing so far. But it's actually even worse because besides this duplication, the fragmentation of the kernel tooling and the processes makes it even harder to implement testing because we have, all the test suites are completely different. And then if you want to do pre-commit testing, you need to intercept patches, which is extremely hard to do. Reporting results is even harder in the kernel, and we have lots of kind of human interfaces, which makes it very hard to automate anything, right? And it's even worse. So let's imagine we actually 7 CIs kind of succeed and actually start testing the kernel. Then developers get 7 copies of each bug report for each bug, right? And probably within a week because some of them will have different latency. And you will actually need to reply to all of 7 of them because if you don't reply on one, another developer may start fixing the same bug looking just at the different report where you didn't say, I'm working on this, right? And also CI people will just think that you maybe lost their report. Also, we see a significant problem with Sysbot that developers need to learn how to actually interact with your system, how to work with your system. So this is very hard even for one system, but if we have 7 copies, then it will be just impossible. Lots of them depend on kind of either one person or a small group of people within a company. So if say that one person is on vacation, then sorry, we didn't get that part of the testing. And lots of them considered kind of personal efforts, so they're kind of not part of the kernel. They, so nobody wants to contribute, right? Because this is the kernel, and this is your thing. Like this is not the kernel's testing. This is say Dmitri's testing. Why would I consider? Or why would I contribute to it? So I think that fragmentation is why we can have nice things in testing and actually make it properly functioning. And if we look at the development process and tooling, then we also have fragmentation, right? All rules for subsystems are different. Obviously, there's no documentation. Running tests for each subsystem is completely different. You can spend literally days and you will not necessarily succeed. Then we have email, Patchwork, GitLab, GitHub, Gerrit. We even have Git versus Killed. We have lots of local scripts running on some local machines of people. And currently, it's not possible to avoid this fragmentation, right? Because nobody have kind of powers to make something their solution, kind of the single way of doing things. So if you want to improve something in your subsystem, you're forced to, create this kind of isolated island where, you do things this way now, but like nobody else uses this. And besides fragmentation, some foundations are simply missing. For example, we don't have such simple thing as user identity. And it's required for lots of automation. For example, we can have a system that will do something on your behalf simply because we can't, say who is that you, right? And we can have a system with shared responsibilities because you can't express what is that group of people, right? And we also don't have change identity. So if you have 2 trees, you can't really say, well, if this change in the other tree, it's like not possible. We don't have base tree commit for changes. We can map code to tests and so on. And besides that, we have lots of literally English-oriented interfaces. So people say reply to patches, apply it, which means that the patch is applied, but sometimes they reply with apply it, but that actually means something else. or they say NAC or no way NAC, but they also say NAC handling needs to be improved, which literally comment on the code in the patch. So if you try to kind of treat this, what is the meaning of those commands, it's like, you can't do this. Yeah, so humans are smart and machine are dumb, so we need to give them a discount. And if we have interfaces that are easy for machines, easy for automation, that are also trivial to represent this in a nice way to humans, right? But it's very difficult to do it the other way around. And as a result, because of this fragmentation, MIST foundation, and English-oriented interfaces, it's become super hard to build anything on top of this. So the feature that is mentioned frequently is like you mail a change and CI adds a test passed tag on your change. And I think it's required to prevent lots of bugs being introduced in the kernel. But building this feature becomes super hard in multiple dimensions because just everything is against you. Things that should be just no problem at all. For example, on GitHub, you can just get a notification about new change with the, this is a change, this is a base tree, you can get the exact source code. In the kernel, it becomes super large problem. There's also no sense of collective ownership for lots of things, so we have it for code, right? If you fix something over there, you don't consider that you contribute to somebody else's code, right? You consider that this is your kernel, which is a great thing to have. But for lots of other parts, like testing, static analysis, tooling, we unfortunately don't have it. And the thing is that useful practices need to be shared and common because single person cannot, address some problems. For example, consider we do commit messages like fix a bug, and then Linus says, hey, I think it would be useful if we actually write proper commit messages, and explain what we're doing. And we say, yeah, sure, that's a great idea. So you proposed it, so now you go and add commit messages to all of our commits, right? Because it's kind of your idea. Or you propose to add comments to the code, so now you go and add comments to all of our code, right? It can work this way. And we need it for example, for fixing flaky and failing tests as well, because currently it seems to be, the only people who care are people who run CI. Yeah, then we have overloaded maintainers who seems to be forced to do too many things manually and invent kind of own process and automation, obviously with no docs. And the group maintainership, as far as I understand, is still not kind of a real thing in majority of the subsystems. And it's hard to implement, right? Because we can't even express identities of people. And for the I think that the only thing that maintainers should do is review the code and kind of stamp it for inclusion into the kernel. I'm not sure what else they should be doing that is not automatable. It's definitely not, not copy-pasting text, not fixing mangled emails, not suggesting to run check patch or at signed off, and probably maybe even not sending pull requests. Because if you say, I approve this needs to go into the next merge window, that should be enough. Okay, so let's try to imagine a better world where we actually have consolidation and we have some foundation so that the blocks nicely fit together, and we have interfaces that are suitable for automation, and because it's easier to build, we actually have much more of it, and we have less duplication, and we have more of a collective ownership and more of a group maintainership because it's much easier to implement. And all subsystems get all of this goodness for free, including documentation, because there's just single copy of the documentation. And as a result, we also have more consistency. Yeah, so let's imagine an even cooler feature. For example, if you get a warning from a zero-day bot about a compiler warning, right? What you do, you go to console, you check out the branch, you double-check the file name, the line number, open it, find the line, try to figure out what's wrong, fix the code, save the file, build, realize that you made some mistake, you open the file again, fix it again, save, build, okay, write the version, diff from version 1, and then send the new version. Where what we could have is actually a static analysis tool post you a comment and say, here's something wrong, and you should you should have this code, and you say, you know, agree, apply this. That's it. Or we maybe could have, you know, stable patch trash queue where we actually look at each patch and decide if it needs to go to stable or not. And obviously it needs to be sharded to be practical. And also with the help of some automation that will pre-triage lots of things. For example, if the commit has fix a stack, it goes to yes. If it is a comment-only change, it goes to no, and so on. Maybe it can be sharded across maintainers as well, so that they suggest what is the, should it be included or not. And large-scale changes. Imagine you change thousands of files in the kernel. Also, you made the change using some semantic code analysis tool. And then what you do, you just give it to your system and say, go submit it for me. And the system splits it into patches, finds the maintainers for each patch, finds the tests, run the tests. If the tests pass, it mails the change. If maintainers approves the change, it merges it. Only if the maintainer leaves the comment, that's where you kind of need to take an action. And this may sound a bit like a, you know, fantastic world, but such system actually exists for years and greatly helps to manage very large code base and kind of improve developer productivity, and more importantly, affect things that developers actually want to tackle in this world. So they don't look at the problem and just say, oh, yeah, this is probably worth fixing, but you know what? I don't want to spend next 2 years of my life on this. So I will probably just not do this. You know, with the help of the tooling, they can be excited to actually do such large changes. Okay, and obviously consolidated testing, where we have significantly less duplication of work, where things are easier to implement because we can rely on the lower level kind of services, and where tests are much easier to run. And ideally, you just say, for example, run net filter tests, like single command, like whatever it takes. You know, figure out the config, build it, run, and give me a pass fail. Or run tests for that file which I touched. I actually don't know what it is, but I touched it, so run the test. And if the test passed, then that's all I need to know. So that's what's required for CI. That's what CIs are doing, but it's kind of currently not possible to, you know, make it available for actual developers. So where we have more collective ownership and where people actually don't mind contributing to those things because that's considered, you know, the kernel effort rather than somebody's personal thing. And also all of the changes that have much higher return of investment. For example, if you deploy a dynamic tool, it immediately kind of affects all of the kernel testing. And where it's possible to do break-in changes, what happens today, people do some change and it breaks all of the testing. And it's kind of simply, currently it's not possible to avoid this, not possible to do kind of graceful rollout of any break-in changes. And also test machine scalability is something that lots of people mention. So the kernel testing may require lots of resources. And if we have a single system, at first it's much easier to get more resources for the system. And the second, we do not duplicate effort, because what happens today with the resources we have, we run all of the same tests on all of the same commits, say 5 times. And we may even get maintainable code. So if I contribute some functionality, so if we have tests that are easier to run, to write, and they're actually executed, people may start seeing benefits of this, and we may have maintainable code. So if I contribute some code to the kernel, I will not need to be around for eternity because I'm the only person who knows how to test this code, right? Or maybe it will be possible to touch some parts of the kernel without breaking them because all of the tricky 1,000, corner cases for this code actually encoded in the tests now. Okay, so it's easy to speculate and easy to draw those, perfect pictures, but is it the right thing to do? So I think it is, because the scale dictates the optimal amount of unification and commonality that is needed for a system. Larger system needs more unification structure to be manageable, and we have quite a large system with not enough of structure and rules, and we kind of losing track of the things. But you may say, we don't like imposing things, right? But I think this is, at this point, this is actively harmful for the project. And second, we do impose lots of things. We have lots of common things, like C, GPL, Git, code style, tags and the commits and other things. And if you think about each of them tremendously helps the project. For example, if you take one of them, say Git, I think it will break lots of things because there are lots of scripts and lots of kind of systems that assume that it is Git and they're built on top of this foundation. But so those things provide quite basic level of services, but the problem is that on top of this we have complete anarchy, we have fragmentation, we have missed things, we have human-only things, and so on. So I think we're kind of long due to actually having more of the unification on the higher levels. And one indication of that is I looked at the full help for the Git command, and you can find pretty surprising things that it can do. So it's kind of version control system, but it can send emails, so why it is sending emails. Or it can parse some files that are extracted from emails. Again, why version control system is doing this. Or it has functionality to manage kind of record-based database in a plain text commit messages. Again, like why? So the answer is that that's just the only common denominator that we have. So if you want anything in the kernel process, you have to push it into Git, right? But we obviously can't have issue tracker and testing support in the Git. Probably that would be a bad idea. So I think we're kind of stuck in a local optima, and current answer for any problem in the kernel is like you do small steps. And the thing is that we can get away from this. The thing is that no amount of small steps will get the Linux as a project away from email-based process. Right? It's actually even worse. So people try to do some improvements, say they try to switch to GitHub, GitLab, Gerrit, or run another local script. And this makes situation better locally for them, but it actually makes situation worse for the whole project because we have now even more fragmentation. So what I think we need to do, we kind of need to make a step back and look at the final destination where we want to be and try to make kind of fourth step to better optima. Yeah, because we have structural systematic problem, and it can be solved simply by some number of local fixes, local improvements. For structural problem, you need a structural solution. So now the last question is how we can get there, and what exactly is the action plan. And I don't have precise answer, first of all, because it's a hard problem. Second, I don't simply tell all of you what you need to do. So I think we need to kind of discuss and try to come up with a solution. I have some ideas about the implementation. So first of all, I think it needs to be, if we're doing this, it needs to be very explicit effort. We need to understand that we're creating the kernel way of doing things that will be used everywhere. So the worst thing that can happen with this is if this will be tried to be downgraded again to the same, you proposed it, you try to do something, over there, and and then the best outcome is that it will die. The worst outcome is that it will only increase fragmentation even more. So second, I think it needs very explicit buy-in from leadership, including Linus, because the current distributed kernel community, it's very hard for it to kind of self-organize for such large radical changes without explicit leadership, because again, nobody have any powers. And the second implication is that then leadership will need to ensure everything they can to make this effort a success, including kind of changing the direction on the way to ensure that it actually arrives to the necessary destination. It may need to use working group approach simply because discussing all things on the mailing list with 5,000 people may be not the most productive thing. Some of the changes may need kind of a carte blanche approach, just simply because that may require lots of changes, and if you need to kind of justify and argue on each small change with everybody, it maybe just become infeasible to do. I don't know, if it needs to be a left project, I don't know, maybe, but companies will need to donate some people for this. And the thing is that companies already spending significant amount of resources. It's just currently they spend not in the most efficient way, I think. So it just kind of, the idea is that they repurpose their resources. And the question is if this can then benefit the companies, testing and processes, because say lots of distros do own testing, they have own tooling and so on, so it would be natural to kind of be able for those companies to also reuse significant part of this, right, because they donate the people. Obviously, it all needs to be open source and probably not this kind of single web system deployed by a single company thing. Also needs to be incremental in multiple dimensions, kind of in the features as we implement them, but also in unification. So the first step may be to have several kind of fragmented things just be unified under a single interface to the higher level and to the lower level. So this kind of fragmentation becomes local within a single block rather than kind of global and affecting the whole system. And the subsystem also, as they switch to this new tooling, it also needs to be incremental. Initially, probably switch one of them, then maybe a few more. It's just important to understand that we're switching all of them rather than stopping after 3 or 5. Yes, and the last thing. So recently, Konstantin Rebetsev wrote a blog post called Patches Carved in the Developer Sick Chains, where he tries to solve some of the problems with email. It's actually different problems. It's like more, let's say, technical problems with the email itself, but yeah, the post talks about the protocol called SSB-APFS, which is kind of email in the sense that people exchange messages, except that it's a peer-to-peer protocol, fully distributed, but it can also have servers for, say, archiving and proxying purposes. It can work offline. It has a strong notion of identity, trust, encryption. And the most important thing for us is that it's kind of meant for high-level protocols. So it's kind of just a transport. So you can imagine that you can just send messages and chat with people, but you can also send a special message, which means I'm submitting a change, which has your patch, your base tree, base commit, or this is the next version of that change, and so on. Or say I am reviewed by me, a special type of message, which will automatically add a tag to the final commit and such things. And there's a company or a system called Radical, which creates a peer-to-peer stack for code collaboration based on one of those protocols. And on the website, they have some examples which may be appealing to some of the kernel developers. So they have a full command line interface where you can do, say, list my patches for review or accept that patch or send the change or list open issues and so on, or add a comment. So I'm not saying that we need to use exactly this. I'm just saying that something like this may potentially be a very good fit for a kernel. And obviously, a web interface for that is also possible to build. So summary, we have a number of systematic problems. And, well, if we don't take any action, well, the current development process will continue to work as it is now, like nothing breaks. So developers may have lower productivity than they could have, and we will have tens of thousands of bugs per release. Security will stay low, and inflow of people will be lower. And fixing the testing, I think, will take significant time and significant amount of effort. So I propose that we take kind of more radical action for the greater benefit of the Linux kernel, kind of looking at the next decades of Linux, growth. So think about, for example, 10 years from now, are we still on email processes and fighting with the same problems? And will it happen if we just, continue doing small changes with no centralization? So now may be the right time for changes. And that's it. Thank you.
Yeah. So we have a lot of, so let's thank the speaker. So we have a lot of people who I suspect are going to want to make some comments, and I do need to allow time for the follow-on speaker. So if you could try to keep your questions or comments short, please stand up and identify yourself. Raise your hand, I'll try to acknowledge you and try to get to people in order, and I'll be passing the mic around.
She's got her laptop. I'll hold it.
Okay. I wanted to ask you a question about more about Ts'o in terms of how do we update stuff, duplicate bugs, or a process on your end? What's the effective way for us to do that? Because I have a few duplicate bugs, and I'm looking at, well, I don't have a good way to update. I can't figure it out. So I was hoping to hear some of that, actually, from this talk, but we can talk offline.
If you could suggest one of the things you discussed here to bring up, say, at a meeting with kernel maintainers that might be going on tomorrow, what would you suggest?
If overall this is what we want to do or not.
Okay.
Other questions or comments?
Way back.
Hello, you mentioned me by name in there, so I wanted to chime in. The stuff that I would love to see a lot of this stuff happen, right? The problem is that the maintainers need to be the drivers for this. I can't come to the foundation and say, this needs to happen because I say so, right? Because I'm just the sysadmin for kernel.org as far as everybody's concerned. I'm just maintaining things running. Mm-hmm. So this needs to be driven by people that Jim Zemlin listens to. If this is to become a Linux Foundation project, like Greg needs to come to Jim and say, this is something that needs to definitely happen because the community is asking for it. The advisory board needs to come to Jim Zemlin and say, this is absolutely overdue. We can't continue like this because this is a pressing problem that is breaking the kernel, and it's things, if we don't change something, we're going to see things deteriorate even further and fragment and everything. And this is pretty much the only way to make this a Linux Foundation project. If we don't want to make it a Linux Foundation project, that's also possible. You can come to Microsoft and say, would you like to make yourself a big name in the Linux kernel community? Make a team of engineers and work with maintainers and see how you can help solve this particular problem without bringing up another web service, like a centralized one. So that's kind of where I'm standing and where I see the problem right now. It's not an easy fix without a drive from maintainers to make this change happen. And since maintainers are very thinly spread, they don't have enough cycles to really spend a lot of brain power on figuring out where it needs to go.
So have you ever heard of the paper, I think it might have been extended to a book, The Cathedral and the Bazaar?
I remember reading something like this, but a long time ago.
Yes. I think it might be interesting in the context of this talk because I think it basically argues I think what you're arguing against is the bazaar model of the kernel, which is exactly why the author argues that's why the Linux kernel community succeeded. So it's kind of a long discussion. I don't want to waste other people's time, but I think that what you're describing is basically, you specifically asked for a push towards centralization, and this paper argues that the decentralized model of the kernel, this fragmentation, is actually what allowed it to succeed because it allows people to have their own agendas and their own ways of doing things.
20 years ago, though. Yeah, literally
yes.
20 years ago.
As we figured more things that actually, good ways of doing things, maybe time to promote some of the, this chaos to actually one solution.
So there's the kernel CI project, which has not been formally announced yet, but a Linux Foundation project in the CI space that I am hoping will be able to take on some of those bubbles that were on your boxes, on your slides. And there are people working on aspects of this, and it remains to be seen how much buy-in we'll get, but I just want to say it's not all gloom and doom. I mean, there are people who see the same problem, and it's actually refreshing to see multiple people just at this event saying basically the same thing, that we need to consolidate and unify around a couple of things. So I'm hopeful that we'll make some progress in the next couple of years. So we'll see what happens.
It just occurs to me that it's largely a scaling problem. If we had enough people, the bazaar model would probably still work, but we don't have enough people or working force to ensure that model, and so we need to think what to do. And your option, I think your option is one option. Having tons of people would be another one.
Mark Rowland. No. Big problem is scale of communication. Throwing more people at that, you now have more communications that have to occur. That doesn't work. That's like the thing mentioned about all the trees that need to backport to. You're now throwing more people in, you lose information because someone doesn't fully understand all the intimate details of the problem they're trying to solve. The next person on loses one more detail, and throwing more people generally does not help.
Time for one more question or comment? All right, well, I will mention that for file system testing in particular, I had actually tried to make the tool that I work on apply for multiple file systems, and I made an attempt to see if I could get other file system maintainers to use my tool, which in my opinion actually does a lot of things better than some of the other tools, and everybody has decided they want to do their own thing. So we've consolidated on XFS tests as how to actually run file system testing. I have utterly failed on making my test runner something that more people are willing to use. And the only approach I've been able to use is I'm trying to get some interns to add, automatic kernel building and bisection and try to add enough features that it is so much more powerful than the other tools that it can generate the attractive force to make it be successful. And I'm trying to do that on volunteer labor because, it's a lot easier that way.
Yeah, this is the thing. We have it's so much fragmented that no single testing effort can get enough resources to actually pass that bar of being really.
It sounds like you're doing the same thing that like 7 of the CI systems are doing, which is adding bisection to make it attractive enough to. So I mean, that's a manifestation of the problem, right? And if there was a really, really good bisect tool, which there was a talk on yesterday, you wouldn't have to do that, right? So we could all specialize if we could make a modular ecosystem.
Yeah, and I think the issue is that none of the existing tools did the one thing I needed for file system testing, and so I was forced to generate my own infrastructure, and that's been the problem. Yeah.
But I think to Dimitri's point, what he's suggesting basically, instead of each of us getting a bunch of interns and people trying to make your system better, we pull those people into this big worker pool to make the community better in general instead of competing with each other or trying to compete.
Yeah, let's make this the last comment. I want to make sure there's enough room for the next talk.
So I think we all agree that everything should be better. and we agree that we need Linus to buy in and blah, blah, blah. But you've got to have a really concrete proposal. Like what exactly should we be switching to? Like we have to take some pain to get to the next local maxima, but what is it?
So we need concrete proposal, but I'm sure that it should not be only me who will, create all of this proposal with all of the details, right?
Maybe.
So and just creating this proposal is lots of work, right? So even that will require kind of a working group to figure out just very high level things.
There is an automated testing working group. So believe it or not, and there's a conference call every month that involves a bunch of people from a bunch of different CI systems. And I would argue that if you want to see automated testing,
portion of this solved, please get on the conference call, please get on the mailing list, and communicate with the other people who are working on this.
But I mean, he's not just talking about testing, he's talking about submission and the whole thing.
Yeah. How do you get patches to test, and how do you send results? For example, kernel say can do this, and it's kind of hard problem, right? It's not solely on the testing, area.
Yeah, so I'm afraid we probably could keep on going for the rest of the day. So let's thank Dimitri, and this conversation will continue. So. Well, I want to get started so you have enough time, though. All right, we already ran a little bit late because the last conversation had lots of good thoughts that people wanted to share. So let's get started, and Shua is going to talk about case self-tests.
So goal for this thing is mostly I want to get some discussion going on what I should do for the next year. And then once a year I kind of do this and give the State of the Union on kernel self-test, and then talk about what can we do the next year. So in the last 5 years we added a bunch of tests. We are about 70 directories, targets, if you will, for the case self-test. So what that means is we have a lot of growth and we have a lot of tests. And more importantly, Linux kernel functional testing group from Linaro, they have been using this to qualify Linux Next, Upstream, and all of the stable releases. So they run a variety of tests, and this slide is credit to Dan Rue and Andrew Roxell. So they run a lot of tests. They show how many tests they are running, various tests. This is a graph showing that. That's a slide from. And I want to focus the discussion on some of the numbers we are seeing. That's my primary goal here. So you'll see, and then also make a decision on we want to, going forward, do we want to, there is this ongoing question that we have. Do we rev match kernel self-test with the kernel, or do we use mainline stable kernel self-test on stable releases? I'll go into a little bit of detail on some of the pros and cons, and then what we are running into, what I want to solve going forward. So you'll see two numbers here. You'll see 4.9 on this all the way on the right side, rev matched, and you'll see a failures, a total of a pass of 45 tests pass and 8 fail, and out of 126, I'm not quite sure the number of tests here, but whereas if you, how many, Dan, do you know the number of tests there?
I think it was 198 total.
Even for this rev matched kernel, for 4.9, all the way.
Whatever it adds.
Yeah, right, okay. 150. And then if you see on this side, on the left side with the 5.3 RC7 self-test, rev matched. So you're seeing 55 failures. That includes, that's the total failures. You can see using rev matched kernel, you're running fewer tests because there aren't as many tests, obviously, in 4.9 kernel self-test, because we keep adding a lot of tests as we go forward. So between 4.9 and 5.3, there is a gap there. So let's come back to this numbers later. I'll go over them later. And then this is the current, there are these 3 different use cases. And then rev matched kernel, that's the numbers I showed. And then we have a k-self-test with the latest table. What that means is it is k-self-test on Linux Next and 5.3 RCs, we do rev match. But when it comes to stables, all the 5.2, I think we're at 14 now, and 4.14, 4.9, all of those 4.19, those are currently latest stable is being used. What that means is 5.2.14 will be used on all of the ones below, including 5.2.14. So let's get to the next agenda, next discussion. So I'm trying to decide, I have always said, I kind of said, well, you will get better coverage if you use the latest k-self-test. But that has pros and cons to them, because latest k-self-tests tend to be a little bit of in a churn situation. So that's proving to be a little bit problematic, balancing coverage and dealing with the test bugs. In some cases, it's mostly, we are looking at features, the guideline for writing tests and is if a feature cannot be tested, because when you're going to run into that a lot if you are in that situation where you're running latest k-self-tests on a older stable, for example. If you're running on 4.4 using 5.4, for example, then you will see several features missing, right, in 5.4. So you will have to have skip handling, graceful handling of skipping features that cannot be tested, ideally. So because if you do not skip, if dependencies are not met, and if you don't skip, they'll all become failures. It'll be a bunch of failures. It'll be very difficult to figure out the status of the situation. One solution is, of course, saying rev match. That is one solution. However, you are going to be missing a lot of test coverage. So I would like to get to where a balancing point where we can continue to run latest stables on older stables and minimize the number of failures we see and coverage, increase the coverage. That's what I want to ideally get to. So that's what we have been trying, and so we have some areas have very active in terms of writing tests, and we are getting, like for example, you won't see C group tests, for example, in 4.9, rev matched k-self tests. So you're not getting that coverage, even though you have C groups there. So there is an advantage to running kernel self-test from mainline stable on older, because we keep adding tests, not just for new features, we keep adding for missing tests in some areas. So some of the numbers here. This is from 5.3.RC7, I think, right? Is the RC7, doesn't matter really. So I'm comparing two different architectures, x86-64 and ARM64. So out of 198 total tests, 63% of them pass, and the 11% failures you're seeing and 18 known fails, they are failures. Known failures means that the LKFT folks went through the list of failures and categorized them as known failures, and they have been reporting. There's a variety of them. I'm going to start looking at that more closely to see what is the nature of the failures. Are they the failures of the tests that they should have skipped, that we should increase the number of skips, or the nature of them? I do not know. I looked at a few of them. They seem like something that should have been skips. That means some dependency file is not found, then you should go and skip. Or it could be that you do not have a dependency. Some dependency, it could even be a tool dependency. Probably a CPU memory kind of test is using LSCPU to run LSCPU and get some information and parse that and take different actions. So it could be those kinds of dependencies. So my goal is to get this number down, both failures and known failures as much as possible. So these are numbers from, this number can be interesting, 5.14 RC. Again, you'll see known failures. This is rev matched with, I'm assuming, K-self-test from the same 5.214, because that's the top of the mainline stable, latest stable. So the same thing will be used on current setup. The same thing will be used on 4.1972, also on 14 and 4.9. So that's the ideal state we want to be in. That is the state we would like to be without these many known failures potentially. So what does that mean to us? Meaning individual test maintainers and myself, and then also CI admins. What does that? So my goal is to improve the process. There is some other, we have been, I've been talking to both Anders and Dan, and we have been going back, and there are some, we are working on improving some of the reporting the process coming into me. And then I'm going to have to go around and ask individual test maintainers to make this a priority to help me solve these problems. I probably will start looking at these known failures and support me in getting the known failures down so that we can make CI experience better running K-self-test, because there is an advantage to doing this, right? Obviously. If these tests get run on all of the stables as well as Linux Next, we are better off for coverage. Any questions? Yes.
Hi, I'm on the Ubuntu kernel team, and this is something that we struggle with from time to time is running the K-self-test against our stable releases. Some of that's, some of it's, like you mentioned, the BPF test suite is very exhaustive, but it's also very complex to backport some of those K-self-test changes along with the code changes. So I guess this idea to use the latest stable release is really interesting to me. I hadn't thought about that. Is there buy-in, do you think, to actually backport those self-test changes to the latest stable?
Correct. So that is another issue because we cannot backport all of them.
Right.
Obviously. So we have to reach a balance point. So I'm actually throwing this idea out. Is this a crazy idea to continue to want to support mainline stable on older releases, as old as 4.9 or 4.4 or even 3.18? all of them? Or do we have a cutoff, kind of an in-between solution? We say, hey, match it with something that's closer to it, so that you're not trying to have full coverage, but you're saying balancing the pain of running mainline stable K-self-test on very old stable, the pros and cons, kind of balance it out and find a sweet point where, say, we're getting enough, we can't get the full coverage that we would get from the mainline stable, but we're reducing the pain of.
My thought on this is it's similar to a lot of any of the other kernel development processes where we're relatively resource constrained. People have limited time. And I completely agree. I would love to have latest tests running on older kernels, but it seems to me that in a resource constrained environment, you have to prioritize what we're working on. And we're already having a lot of trouble getting people even to write tests for the latest kernel.
Exactly.
So if we can get the test environment similar to how we have a warning list build, right? If we don't have failures, like the latest kernel, everything should pass. And that seems to me to have the highest priority. So once we get to the fact that get to the point where it's not noisy, where it is truly has meaning, and you say, a test failed, you can't submit whatever broke this. Like, you have to fix it because that's the only warning in the entire build. And we run the entire test suite, and that's the one that broke. That stands out really strongly. That seems like the highest priority, with the next being coverage, adding as much coverage as possible. And I think once the urgency of that starts to diminish, then we move to saying, okay, now we can start pulling this back to stable trees and see what we can get. But I think once we get to 0 warnings, eventually the old kernels will have 0 warnings also, and those tests will be meaningful on those kernels.
Right, only if there is that, the issue of backporting. So you can't just backport. Yes, so my priority, I have always done, that's how it grew from 5 to 70. My priority is to get tests in. So that's my highest priority. So I'm completely with you, and Michael is saying the same thing. So yes, that's what we want. Now, how do we make it easier for CI, because they are adding a lot of value? Because if you look at individually, I run some of the tests, and BPF folks do run their tests, and every single maintainer around here or developers in subsystems, they focus on their tests. And when I am sending my pull requests, I focus on the bigger thing of overall testing. And what Dan and Anders are adding is that they are taking these tests and they are integrating. They are not only integrating the tests themselves, they're also looking at kernel bugs. So they are bringing a lot of value to us in the development process. So I would like to help them so that they can help us. So that's one of the things. So that's where the balancing act, that's why I'm throwing this out to ask for your input.
So I have 2 comments. One on Kay's comment is that the people who are most affected by this should scratch their own itch. And I'm in the embedded space where we haven't run a mainline kernel ever. So we're the ones on LTS, so it seems like that group ought to bear the burden of doing coding and triage or whatever is required to make it so that you don't have to rev match. If we want the extra coverage, we should put in the work. So that's fine. I'm willing to do that. I'm willing to push other people in the embedded community to do that. But my other point is that I think it seems, I don't know the code base that well, but it seems like there might be opportunities to put some of this handling in a library or a shared routine, the skip list handling. I know that
it already does that.
Okay.
It's all in the common code. That's how common handling works.
Okay.
So, but yes, tests do need to return. Some of that knobs happen in the test. That's where we are seeing some issues here.
I agree that getting tests written is the first priority.
and that the second, I agree with you, Keys, that the second priority is getting it working better when it's matched. And if that happens, because if you noticed in that slide, when we run on mainline, we still have something like a 30% failure rate.
Yeah.
That's like an ideal situation. So that's going to get worse over time when that becomes 5.4, and then we're testing that with like, you know, a kernel in 2 years. So if we prioritize that and got that working well, it would help with stable as well.
Yes,
and
it does.
I think the place to apply the resources would be then on getting current tests working with older kernels and not necessarily trying to maintain like every branch of self-test over time, because that's also, you know, has a huge cost over time.
No, we won't be able to do that, definitely, right? I mean, there is a minimal effort we can do in terms of improving rev-matched kernel 4.4 on 4.4. So that's a good point. Let's get these things done. And then I do need help from the LKFT folks themselves, that I would like more reviews when they come in and say, oh, this test is should skip and it's not skipping. So I would like to be able to more eyes on the code from the angle that you are looking at your use case, and you need to look at that use case. And I've talked to, I'm asking for help there. And yes, we do need to figure out a different way. So there is this other model that I need to worry about too, because the way the current maintenance works is tests flow through individual test maintainers subsystems, partly because there are dependencies. So I'll have to work with maintainers and figure out a better way where we can, some of these come in through that as well, because they don't get as much reviews. Because their individual test maintainers are focused on tests themselves, which is good, that's what should happen. Some of the framework stuff, sometimes I miss, sometimes I don't have visibility to some of the stuff if it goes through. So there are some process issues also I need to work on getting to a point where it's working well. Is there a question in the back? Or?
Yeah. Any other questions or comments?
Yeah, like as an upstream maintainer, all my tests are focused on upstream, but I'm absolutely happy to have people who are running them downstream send me fixes to make them work there. And I think in a lot of cases it's often trivial. It's like, does this syscall exist? Mm-hmm. Sometimes there's hard cases like, does this bug exist, which is tricky. But in general, I think a lot of the tests should be able to run, the mainline test should be able to run clean against stable with a few little tweaks. But maybe I'm wrong. Y'all can tell me.
But
I think, yeah, there's definitely a willingness to have little warts in the tests if that's what we need. Right. It's just all the upstream developers, that's not their focus. They're not thinking about that when they're writing tests.
So that's really.
So I think, I agree with Tim. Like the people downstream need to do that work because, yeah, upstream, we're just trying to get tests in as fast as we can.
Right. So Michael, being one of the ones that helped put a lot of the K-self-test generic code, I'm not concerned about PowerPC at all. So you look at that. Yes, there are some individual test developers, sometimes maintainers. They are worried about the content of the test. That's where it should be. So that's why I'm trying to take this as a general K-self-test problem that will fall, obviously, under my responsibility. I need support, more support from individual test maintainers. So when I go and say, this test is failing, I want to be able to get response saying, yeah, we will help you fix. And then you're absolutely right. We can get more traction if we focused on the latest.
Yeah, and I'm in the same position. Like, sure, I'll take backports to make things work better with older kernels. To that end, I think it helps to classify a test, because there's testing that a bug doesn't exist, which that should definitely pass on the stable kernels, because if it was a serious enough bug to add a test for it, that should be fixed in the stable kernels also. So absolutely I want to backport that. Feature additions get weird because sometimes a feature got backported. So if it's in the kernel and it's hard to detect, or like that starts getting strange. But I think maybe having documentation somewhere, maybe it already exists and I just haven't found it, to say, here are the classes of tests we'd expect in the backporting. You know, what we'd expect for a bug fix test, the bug should already be fixed, and do this, and like sort of break down all the pieces, and probably the top of that is all your tests should pass in mainline as the first requirement. Because that's where with any changes, I've always pointed people at documentation to get them to understand.
So there is documentation that exists, and then there is I probably should turn my slide set that I linked from the K-self-test wiki into a proper document, potentially. When I review, I always ask these questions when I'm doing the reviews. Unfortunately, there are some patches that get in without getting that framework review. That's one of the things that I'm trying to fix also. I review, and I'm asking help from others to review as well. So, and then if you are also individual test subsystem maintainers are also aware of these problems, that's why we're discussing this, then you will be looking for them as well, yourself, right? Because there are 3 kinds of dependencies that we're looking at. Tool dependencies and such, we can handle that in the framework. The second one is reporting skips and recognizing stuff. I don't want to burden individual tests to do that. The third part is the variations on how do we recognize. There is 3 kinds of things we do. Right now, the scripts that are dependent on a module, when they are loading, they try to, that's the thing that if the module doesn't exist, you skip and you go through that process. And the second kind of dependency is config option dependency and architectural dependency. So we have been making improvements in that. So it's not 100% yet. That's where the continuous improvement comes in. It's almost, sometimes it's like shoveling snow, shoveling while snow is falling, because we have tests coming in as well. So they are bringing skips. They are bringing these kinds of dependency checks, missing dependency checks. And the third one is also system calls. So that falls into sometimes the category of test content itself. So what that means is that if a system call, based on the system call returns, you might have to say feature is missing and skip versus. So there are 3 or 4 different kinds of dependency checks that have to happen. So some of them fall into test content. I look at the framework closely. And then if somebody sends a test script and say, if there is a root check, another aspect is coverage. That means if you have 10 tests, but only one of them requires a certain dependency and rest can run, so that just that test should fail on that dependency or skip on that dependency, run other 9. And then coming back to that, I look at those kinds of things for framework, high-level framework things, and I do give comments on that. What I can't potentially have either expertise or to tell the nuances of the last one we mentioned, that depends on actual feature and how that somebody has to know. I have to have the knowledge of what should happen, and I can't. I just won't be able to do that. So that's where I need help. So it's probably a process of asking. That's why I'm asking support from individual test maintainers, saying, I would like to have awareness that the value CI is adding, and that how can we make it easy. So.
Hi. I think you probably covered this in the last few minutes, but so I work on the live patching self-tests, and generally, we've gotten to the point where we kind of have all the tests that we initially, kind of wanted, and when we have patch sets up for review that add new features or heavily modify or subtract features, we like to see a self-test come along with that. And I think our perspective is that when we write those tests, so that we are targeting the latest upstream, what my patch set is implementing. And so I just wanted to share with you, like I don't think we've ever thought of the possibility of somebody just grabbing the upstream like live patch self-test and then running that against a kernel from a few versions past. So if that's something that people want to do, then I think we'll need a way to kind of express that, I guess, somehow in the tests. It's very easy for me if I'm backporting self-test back to say rel, because I could just bring all the associated kernel code that supports those features. But if somebody's not as familiar with that and wants to run again upstream k-self-test against something unstable, that's something that I don't think we had kind of anticipated.
Right. So your test is a good example of a test coming in that can provide coverage on stable, right? If you have live patch in some of the stables. So because you're adding a new coverage area for the stable. Because if you have supported in the in the stable live patch and stable, and then you're adding a test new. Right. So we have to figure out a way to do that, and we can work together on getting that.
So maybe everything now looks as a nail to me, but it seems to me the answer to the misdependencies is the testing. So that somebody sends is testing, simply checking. So somebody sends a change with a new test. It's within reasonable latency run on the older version of the kernel, and the review gets message that this test is broken on an older LTS, and then developer fixes this even before this is submitted. I don't think that throwing in more people and eyes on this problem is kind of scalable and reliable solution, and also not the right way to spend.
So
human
Linux Next, we do that. That's the whole integration process in Linux Next. So we do.
Also for the older releases, because that's what the problem we're trying to solve, and within reasonable latency of the patch being mailed.
Right. That's one of the things we have been talking about. So that when during that process of merge window, that potentially we run it on stables as well, if that is a supported use case.
Yeah, so one observation is that in the file system space where XFS tests is always out of tree, one of the models that we've developed in ext4 is when we add new features, we actually add a zero-length file in sysfs, so /sysfs ext4 feature name, because that's how we can make the tests easily key off of whether or not a feature gets backported to, say, an Android kernel without having to do explicit version checks. And since we know that that's just something that's going to happen, we just develop that as part of our feature development sort of process. And I think this goes in with a lot of stuff. K-Unit's going to be the same. Sometimes you have to make changes to how you develop your features to make it be more easily testable. So
I think I have a couple more things I want to cover, but yeah, let's go ahead.
Real quick.
That's
I just want to say that NapArmor, we do the same thing. We do feature flags, and it makes testing so much easier. You can key off that, and it just makes it a lot easier to know if we've backported a certain feature or what kernel has that feature. And then I want to touch on Dimitri's point that if we're able to do automated testing of stable kernels based upon the latest changes in TIP, I mean, not only would that be able to tell us, it would also let us know what's missing in those stable kernels. Like maybe there's a fixes tag that's missing on that patch because it actually does fix a bug that needs to be backported, and otherwise it wouldn't make it back to stable. So if a new test or a new change causes old kernels to fail, then it's a really nice feedback loop to know that there's a real bug here that needs to be fixed and backported.
So that's one of the reasons that's one of the things I have in mind when I have been talking about it. So that better coverage, better coming, and all of that. And then another thing is fixing these. When sometimes if you find a problem like that, just send me patch, because that would be something we have to prioritize and put that in. So, how are we doing on time?
Yeah, you have like about 7 or 8 minutes.
Okay. Okay, great. So I think we kind of, so the other things, that was the highest priority that I was trying to get answer for. And the other things is that we are increasing ARM coverage. Last year when I did this, I asked, hey, we're missing ARM tests. So we have added a bunch of them. It still needs work, but you can see from the numbers that number of tests that run on ARM and we need driver coverage, and we're improving that. And so identifying dependencies, I kind of covered that. That is a part of the CI thing. We have to identify dependencies. Like, for example, x86 test, that is something individual test maintainers can do also. Thinking about the dependencies and do they want to handle that in their shell scripts or wrappers that they run. Because x86 does that. 32-bit libraries are missing, then at least it spits out and says, hey, load these, at least instructions on how to load. So we have to continuing to do that. Some of the things we probably can do at the framework level, which I can. We can make that happen, but some of that falls into the individual tests as well. So the last item here probably is another thing I wanted to discuss, because K-build integration has been because it sits under tools, it has been somewhat problematic. It kind of sits there. And it's not well integrated with K-build at the moment. And Michael, okay, yes.
I think the question I have for sort of distro packaging people is, should it be integrated with K-build?
Right.
Or would it be better if we just used Meson or whatever,
right,
some other thing?
Right.
You know, because it's K-build's for building the kernel, and this is not kernel code. So I'm not sure. I feel like K-build might actually be worse for packaging people, but I'm not sure.
Right.
Because that would sort of mean you have to build it with the kernel, whereas now you can actually, it's standalone. You can build it separately. So yeah, I don't know.
Right, that's actually a question
I got a thumbs
to
up from
say,
Kate.
should it be integrated with K-build? Because there have been, okay, so that's actually a question, yeah. So it looks like there is a opinion on should it be integrated or should it not? So that's
as long as you don't lose any features. So cross-compile is absolutely essential for an embedded world. So don't lose K-build output, don't lose O equal, that type of stuff. As long as you don't lose those features, then sure, why not?
we have to, yeah, that's why I'm asking this question, because some of the things, I'm sorry? Some of the, okay.
So, yeah, so the one thing I'll add here is I think it really depends on who you want to be running the tests. And I think that's actually one of the issues with GCE XFS test versus CI, which is if you are building a test system that is designed for use for developers, you're going to optimize it in a certain direction.
Right.
If you're trying to build something so that it can be used as part of continuous integration or by a distro builder, it's going to get pushed in a different direction.
Correct.
And the challenge is, can we make a system that can be easy for kernel developers and maintainers who are trying to evaluate an incoming patch, right? Versus people who want to run it under continuous integration or as part of a distro build process, right? And those are really, really different, right? So
we are, right now, I am heavily tilted towards developers, and that's the primary goal for this subsystem, of course. And so that's the balance point. So that's why.
Is that arguing for K-build integration or against it? I'm not sure.
I'm not arguing for K-build integration with this last bullet item. I'm not. I'm asking because it keeps coming up. So I keep explaining that I would like to keep this as a easier maintainers, developers. because that's why I don't entertain the idea of integration with Jenkins or integration with all sorts of other things. No external dependencies. So I'm not, what I am asking is, because I keep hearing, oh, it's not integrated with cabled, we can't run. Or we can't do this because we can't run. Because of some of the features that, that automatically come because of cabled. Because we're duplicating a lot of the stuff. I have done it, Michael has done it. We do the building out of tree. When we run K-self-test, people come and say, well, our repo repo gets dirty. We need to run make repair. And then, we have had these discussions before. So it becomes harder and harder to bring the features duplicate cabled features. It's not worthwhile to do that. So if that is one of the things that developers want, which it seems like the case, some developers don't want to run this because their Git repo gets dirty, then we need to address that as a developer requirement.
Right. And I suspect the main thing is what developers really want is no matter what their workflow, whether they're using a O equals subdirectory or something else, they want to be able to run like at most, it should take less than, 15, 16 characters to type, right? If you have to, run /tools, /scripts, kunit, -j, whatever, right? The longer it takes to run, to type, the harder it is.
Well,
and that can be both and, right? I mean, that just means you need to have a, make whatever that runs that long command. It doesn't mean that that has to be the only way you run K-self-tests.
Michael?
Yeah, I was just going to say one of the things that we still, I think, support is some of the subdirectories of self-tests. People want to be able to build that self-contained. Like
yes.
The x86 people want to just be able to run make in their directory.
Right.
And so, kbuild would break that, I think.
Kbuild will break that,
and possibly one of the funky new build systems would also break that. But maybe we're at a stage where we can say that's not a feature anymore. But yeah, I guess what we have now was very minimal to, put a little bit of structure around and not impose anything on the test writers.
Right.
And, finding that balance is tricky.
Right. So you can run K-self-test with doing make K-self-test very easily, or make K-self-test with a few targets if you want to. So it's all documented in the K-self-test document, by the way. So it's a matter of going and looking at it. But I think part of it is that people have their own workflows, different developers and maintainers. And then they integrate it into their testing, some of this workflow, like networking and BPF. So that's one of the reasons I have been continuing to support all the existing use cases. Like, for example, you can run make K-self-test and give the directory name, directly invoke that build and test. So, and it's a long path name. So moving it up, might solve, with or without kbuild integration, might solve that problem. That's another question. But that means the stable fixes going into stable will be difficult. So that's a second thing, that if we can make it more visible if we move it up to right under the root. So that's a separate question based, not necessarily coupled with kbuild. So how do people feel about that? So, well, backporting to stables becomes a little bit of a problematic thing, right? If you path changes, or is it not a problem?
Can I just ask a quick question while I have the microphone? Apologies if this has been mentioned. I couldn't make the start of this session. One thing that came up when I was reviewing some of the ARM tests recently is it's not completely clear whether K-self-test should be working against any random version of the UAPI headers. I think by default, you tend to if you just include like Linux/blah, you tend to use whatever headers the toolchain was built with or the host headers. Should we always be using the kernel, the UAPI headers for the kernel tree that we're building in and make sure those are installed somewhere?
So yeah, go ahead. Is the second part to that question, or is?
No, that was all of it, really.
Okay.
There may just be some wiring up that we missed, but.
You can specify, the K-self-test should run with the headers that is rev matched with the kernel.
So we don't expect it to work with other versions of headers then?
Correct.
Okay.
Because it'll have header dependencies, and there are some tests that go install their headers. So that's a part of the install process. So.
Okay, I'll take another look at that.
So I think we're into lunch. I think there was one last question, and.
Yeah, so I was just pointing out, you brought up the question of if it's going to be harder to backport patches to stable if we move the directory. But I think we aren't settled on whether or not we're going to backport the changes. So does that even matter?
So we do backport fixes, right? We do auto selection, and we do several auto selection. So
Greg, do you have a preference?
So I was going to say, if you tell me what directory you're moving things to, if you tell me you're moving directories, it doesn't bother me. We've had many subsystems do it. Networking's done this, media's done this. This would be trivial.
Okay.
Oh, no, I'm not answering that question. I'm answering the question about stable backporting patches. Don't worry, moving directories, do not consider me in that. Do what's best for you.
Okay, that sounds great. Thank you. Thank you. I'll probably go ahead and, I'm going to go ahead and move it in that case. K-build integration is a separate issue, so, okay.
All right,
And
so
then,
I think we're about out of time, so let's thank Ts'o, and we can continue this later. Yep.